Step outside with me tonight. Somewhere dark. An autumn sky. No telescope. Just your eyes. Find the constellation Cassiopeia. 5 bright stars in the shape of a crooked letter W. And slide your gaze down from the deeper half of the W until you catch a faint grey smudge, about the size of a grain of rice held out in front of you. Most people live their whole lives without noticing it. It is the farthest thing a human eye can see, and it is falling toward us. That smudge is the Andromeda galaxy. It weighs about 1 trillion suns. And right now, while you watch this video, it is closing in on our Milky Way at roughly 250,000 miles per hour. The 2 largest structures in our corner of the universe are on approach. And when they meet, more than 1 trillion stars will crowd into the same region of space. Here is the strange part. The astronomers who model that meeting expect the number of stars that actually hit each other to be very nearly 0. 2 storms of stars, passing through each other like ghosts. Tonight, we find out how that can possibly be true. And the answer will change the way you see every galaxy, including the one you live in. I owe you 2 secrets before we finish. First, that famous collision, the one every textbook calls a certainty. It was quietly called into question in 2025, and I will tell you exactly what changed. Second, there is one place in our galaxy where tonight's rule breaks, where stars really do collide. And what is born there should not exist. If you love exploring the depths of space as much as we do, take a second to like this video or subscribe. It helps this channel reach more curious minds like yours. Now, let's begin. Go back to that backyard for a moment, because I rushed you, and this smudge has earned a slower look. The light landing on your eye right now did not leave Andromeda this evening. It left about 2.5 million years ago. When those photons started their trip, there were no human beings anywhere. Our ancestors in Africa were just beginning to knock stones together. And every single thing you would recognize as history, every pyramid, every empire, every language, every name, happened during the last tiny fraction of that light's journey. You are not looking at a place. You are looking at a postcard mailed before your species existed, delivered tonight, to your backyard, for free, and the sender is enormous. Andromeda is a disk of roughly 1 trillion stars, stretching more than 200,000 light-years from edge to edge, tilted toward us like a coin caught mid-flip. The grain of rice you see is only its bright core. If your eye could gather all of its light, Andromeda would span about 6 full moons laid side by side across the sky. There is a monster hanging over your neighborhood every clear night, and it is so far away that it whispers. Now for the part almost nobody standing in that backyard knows. The monster is getting closer. We found that out in 1912, and the discovery belongs to a farm boy from Indiana named Vesto Slifer. He worked at Lowell Observatory in Flagstaff, in the brand new state of Arizona, and his job was patience, night after night. He aimed a telescope at the Andromeda smudge and fed its faint light into a spectrograph, an instrument that spreads light into a rainbow and reads the fingerprints of the elements inside it. Collecting enough light from something that dim took hours of exposure across multiple winter nights, with Slifer standing in the cold, guiding the telescope by hand. When he finally developed his plates and measured the fingerprints, they were shifted toward the blue end of the rainbow. And a blue shift means one thing: approach. The smudge was coming toward us, and it was coming fast, hundreds of miles every second, a speed that made it one of the fastest objects anyone had ever measured. Keep in mind, in 1912, nobody on Earth knew Andromeda was a galaxy. Astronomers argued about whether it was a little cloud of gas nearby. Slifer had clocked the approach of another galaxy more than a decade before humanity learned that other galaxies existed. Account for our own sun's motion, because we are orbiting the center of the Milky Way, and that motion muddies the raw measurement. And the honest number comes out like this. Our galaxy and Andromeda are closing the gap between them at about 250,000 miles per hour. That is New York to Los Angeles in a little over half a minute. It has been true every second of your life. It was true while the Roman Empire rose, and while the dinosaurs died, and it will still be true tomorrow morning while you pour your coffee. On the timescale the universe keeps, our sky has a delivery scheduled, roughly 4 to 5 billion years out, and the package weighs 1 trillion suns. Picture the arrival. Because astronomers have, in detail, with supercomputers, the smudge grows, century by century, millennium by millennium. It swells from a grain of rice to a plate, from a plate to a wheel, until a tilted spiral of light hangs across half the night sky, close enough that its individual star clouds glow like distant cities. The two galaxies reach for each other with gravity first, stretching, warping, pulsing long banners of stars out of each other's disks, and then they pass through one another. More than 1 trillion stars, 2 entire galactic populations, occupying the same space at the same time, at closing speeds of hundreds of thousands of miles per hour. So here is the question that should be growing in your mind. What does the collision sound like from the inside? How many stars slam into each other head-on, in the largest impact our sky will ever stage? The models give an answer, and the answer is the reason this night exists. Across that entire cosmic pileup, the expected number of direct hits between one star and another star is very nearly 0. A few unlucky pairs in the crowded cores. Maybe. Across the rest of 2 entire galaxies, essentially none, the disks will tangle, the banners of stars will fly, and star after star after star, 1 trillion times over, will sail past every other star and touch nothing at all. Sit with how wrong that feels. If 2 swarms of bees flew through each other, you would expect collisions. If 2 crowds ran at each other across a stadium, you would expect bruises. 2 galaxies are the biggest crowds in nature, and they pass through each other like a rumour passing through a room. There is only one way that can be true. The crowd is a lie. A galaxy looks packed, looks solid, looks like a glowing city of light, and it is almost entirely gaps. The stars that make a galaxy visible are physically tiny compared to the ocean of nothing they float in. So tiny that when 2 galaxies interpenetrate, hardly anything is actually there to hit anything else. The question in our title sounds like a riddle about darkness. It is really a riddle about scale, and the scale is going to get stranger every chapter tonight, until the emptiness stops being a fact, and becomes something you can feel in your legs. But we have a problem to deal with first, and the problem is your own memory. Right now, somewhere in your head, there is a photograph fighting me, a gorgeous spiral galaxy, arms packed with light, 100 billion stars, shoulder to shoulder. The screensaver, the poster, the textbook cover. Your gut trusts that picture more than it trusts anything I just said. And your gut is being fooled by the most honest liar in science. Every one of those photographs is telling the truth about light and misleading you about distance. And the best way I know to prove it starts in an office in Baltimore. In December of 1995, where the director of the most expensive telescope in history is about to spend 10 days of its time photographing a patch of sky with nothing in it. His colleagues think he is about to embarrass the entire field. What his gamble reveals will hang in museums for the rest of our lives. The Hubble Space Telescope nearly died young. It launched in 1990 in front of the whole world, and within weeks the world learned its giant mirror had been ground ever so slightly wrong. A flaw thinner than a sheet of paper that blurred every image it took. It became a late-night punchline, a billion-dollar lemon in orbit. Then, in December of 1993, astronauts flew up and fitted it with corrective optics, eyeglasses for a telescope, and Hubble finally opened its eyes for real. By 1995, it was the most in-demand scientific instrument on Earth. Astronomers fought over every hour of its time the way heirs fight over a will, which is what makes Robert Williams so interesting. As director of the Space Telescope Science Institute in Baltimore, Williams controlled a small personal reserve of observing time. A director's allowance meant for bold ideas, and the bold idea he chose horrified people. He proposed pointing the world's most oversubscribed telescope at nothing. A tiny patch of blank sky just off the handle of the Big Dipper, chosen precisely because it was empty, with no bright stars, no known galaxies, no targets at all. The patch was absurdly small, about the size of a grain of sand held out in front of you. A 24 millionth of the sky. Colleagues warned him the images might come back black. Some said outright that it was a waste of a national treasure. And, in an era when Hubble's reputation had just barely been rescued, a famous failure was the last thing anyone needed. Williams later admitted he figured that, if it went wrong, he would simply have to resign. He scheduled it anyway, for the week of Christmas, when the holiday lull freed up consecutive orbits. For 10 days in December of 1995, Hubble stared at the empty spot. It did not blink. Orbit after orbit. 342 separate exposures, each one drinking in photons too faint for any human eye. All of them stacked, aligned, and added together into a single image of nothing, except it was not nothing. When the combined picture came up, that grain of sand of blank sky contained roughly 3,000 galaxies. Not stars, galaxies, spirals, ellipticals, smudges, shreds, colliding pairs, galaxies stacked behind galaxies going back more than 10 billion years, crammed into a patch of sky you could blot out with a pencil tip held at the window. They called it the Hubble Deep Field, and it rewired our species' sense of address overnight. Point that same pencil tip anywhere in the sky, any random spot over your house, and you are covering thousands of galaxies. The gamble that was supposed to end a career instead produced one of the most famous images in the history of photography. Now, here is why I brought you to Baltimore. Because the deep field teaches 2 lessons, and everybody hears the first, and almost nobody hears the second. The first lesson is the famous one. The universe is stuffed with galaxies. Hundreds of billions of them at least. Fine. The second lesson is quieter, and it is the key to our whole night. Think about how that image was made. 10 days of accumulated light, hours upon hours of exposure, gathering photons one by one, so that things far too faint for any eye became bright and bold and solid looking. That is not how seeing works. That is a trick. A wonderful, honest, scientific trick. And every beautiful astronomy photograph you have ever loved plays the same one. The camera piles up light over time until the faintest glow looks like a floodlit wall. Then it takes structures tens of thousands of light years deep, with unthinkable gulfs between every point of light, and flattens all of it onto a single plane, the way a photograph of a forest taken from a mile away compresses every tree onto one flat curtain of green. Billions of separate, isolated pinpricks, each one drowning in its own private ocean of black, gets smeared together into what reads to your brain as glowing liquid. The photograph is truthful about every photon. It is deeply misleading about every distance. You have seen this trick with your own eyes. By the way, if you have ever stood under a properly dark sky, out in western Kansas, or up in the Montana backcountry, or on a desert road in Nevada with the engine off, that pale band arching overhead, the one that gave the Milky Way its name, looks like spilled milk, like a solid ribbon of glow. Point a decent pair of binoculars at it and the milk shatters. It breaks into thousands of individual stars, then thousands more behind those, grains of light all the way down, and between every grain and its neighbours, blackness. The ribbon was never a ribbon. It is countless separate points, so far from one another that their light blends only because your eye is too small to tell them apart. Your own retina has been running the deep field trick on you your entire life, and the points themselves are smaller than you think. Every star you have ever seen, with your eye or through any backyard telescope, is a dot with no face. Even our closest stellar neighbours never show a disk the way the Moon or Jupiter does, because a star is under 1,000,000 miles wide sitting trillions of miles away. And at that ratio, the mightiest sun shrinks to a mathematical point. A galaxy's portrait is painted entirely with dots like that. The painting glows, the canvas, which is to say, almost all of it, is empty. And the emptiness never shows up in the picture, because emptiness does not emit light. Photographs are a census of everything that shines. They are silent about everything that doesn't, and tonight is about everything that doesn't. So when your gut holds up that poster of a packed, blazing spiral and says, "This thing cannot possibly be hollow," you can tell your gut the truth. The galaxy in the photograph is real. The crowding is an artifact, born of long exposure and flattened distance. A portrait of one part of the galaxy in 100 billion, with the rest cropped out for being too dark to develop, which raises the obvious question: if the pictures mislead us, how do we know the real distances? Who actually measured the gap from one star to the next? And the gulf from our galaxy to the smudge in Cassiopeia? Somebody had to turn the flat postcard back into 3 dimensions. And it happened on a freezing October night in 1923, on a mountain above Los Angeles, at the eyepiece of the largest telescope on Earth. The man in the cold that night was a Missouri lawyer's son who had promised his dying father he would give up the stars. On a single glass photographic plate, he found one flickering point of light, crossed out his first guess about it, and wrote 3 letters next to it in red ink. Those 3 letters blew the walls off the universe, and they are the reason we know, down to the decimal, just how empty a galaxy really is. On the evening of April 26th, 1920, several hundred people filed into an auditorium inside the Smithsonian's National Museum of Natural History in Washington. Upstairs sat the dinosaur bones and the stuffed elephants. Downstairs, 2 astronomers were about to argue over the size of everything that exists. Because in 1920, the human species genuinely did not know whether the universe contained one galaxy or billions of them. That is not an exaggeration. Your great-grandparents were alive. There were cars in the streets and radios in the shops. And nobody on Earth could tell you whether the Milky Way was the whole show or one snowflake in a blizzard. The whole fight came down to those little spiral smudges in the sky. Hundreds of them by then, logged in catalogues, glowing in long exposure photographs. One camp said the spirals were small whirlpools of gas. Nearby, minor decorations inside our one and only galaxy. The other camp said each spiral was a full galaxy in its own right, an island universe so far away that its 100 billion stars blurred into a wisp. There was no third option, and the gap between the 2 answers was a factor of thousands in the size of reality. Arguing for the first camp was Harlow Shapley, and I need you to meet him properly, because he is one of the great long shots in the history of science. Shapley grew up on a hay farm in Missouri, dropped out of school with the equivalent of a 5th grade education, and worked as a teenage crime reporter, covering drunken brawls and oil town shootings in Kansas. He saved his money, went back and finished school, and showed up at the University of Missouri planning to study journalism. The journalism school had not opened yet, so, by his own telling, he opened the course catalogue and started reading majors from the front of the alphabet. He could not pronounce archaeology. The next subject on the list was astronomy. On such things turn the careers that measure the cosmos. By 1920, the farm boy had used the giant telescopes of Mount Wilson in California to do something magnificent. He had mapped the true size of the Milky Way, and found it far larger than anyone had believed. a disk hundreds of thousands of light years across with our sun demoted to the quiet outskirts. Shapley walked into that auditorium as the man who had just supersized our galaxy. And to him, a galaxy that big had to be everything. The spirals, he argued, were pets. Local, small. Arguing for the island universes was Heber Curtis of Lick Observatory. Older, silver-tongued, armed with photographs of spirals edge on, with novae flaring inside them, with every circumstantial clue that these things were distant cities of stars. The two men made their cases and took their shots. And history calls it the Great Debate. And here is the truth about that famous night. Nobody won. The evidence was not there yet. Both men went home believing what they had believed at breakfast. Because the argument could not be settled by rhetoric. It could only be settled by a measurement. And the measurement needed two things that did not yet exist together in one place. It needed a ruler that worked across millions of light years, and it needed a telescope big enough to use it. The ruler had actually been forged already, a few years earlier, in a room at the Harvard College Observatory, by a woman most of that Washington audience had never heard of. Her name was Henrietta Swan Leavitt. Harvard employed her as a computer, which in that era meant a human being, almost always a woman, paid about 30 cents an hour to measure star images on glass photographic plates. Leavitt was largely deaf, meticulous beyond belief, and assigned to the tedious work of cataloguing variable stars. Stars that brighten and dim in repeating cycles. In the plates of a nearby star cloud she logged hundreds of a particular type called Cepheids, and she noticed something that no one had ever noticed. The brighter a Cepheid truly was, the slower it pulsed. Bright ones throbbed lazily over weeks. Faint ones flickered in days. The rhythm told you the wattage, and that changes everything. Because if a star's blink rate tells you its true brightness, then how bright it looks from Earth tells you how far away it is. The same way you could judge the distance to a lighthouse if someone told you its bulb's wattage in advance. Leavitt published the relationship in 1912. She had handed astronomy a tape measure for the universe, wound up inside the heartbeat of a star. She was paid her 30 cents an hour. She kept measuring plates, and she died in 1921, so quietly that 4 years later, a Swedish mathematician began paperwork to nominate her for the Nobel Prize. Not knowing she was gone, the telescope came next. On a ridge above Los Angeles called Mount Wilson stood the largest eye on the planet. A telescope with a mirror 100 inches across, so massive that its parts had been hauled up the mountain on mule trains and trucks crawling along a cliff-edge road. And working there, by 1923, was a tall Missouri lawyer's son named Edwin Hubble. Hubble is the second Missouri boy in this chapter, and his road was the opposite of Shapley's. Everything came easy. Star athlete, Rhodes Scholar at Oxford, movie idol looks, and one heavy anchor. His father, a stern insurance man, considered stargazing no way for a man to make a living, and pushed his brilliant son into law. Edwin obeyed while his father lived. He studied law at Oxford, came home, taught high school and coached basketball. A man visibly parked in the wrong life. Then his father died, and Edwin Hubble, nearly 25, walked away from the law and back to the sky, reportedly telling a friend that he would rather be a second-rate astronomer than a first-rate anything else. By October of 1923, he was 33 years old, sitting in the freezing dark inside the dome of the 100-inch, aiming the biggest telescope on Earth at the Great Spiral in Andromeda. On the night of October 5th, running into the small hours of October 6th, he exposed a glass plate of the spiral's outer arms. Developing it, he spotted what looked like 3 novae, 3 exploding stars, and he marked each one with the letter N. Routine work. Novae pop up in the spirals all the time. But Hubble was careful the way Bessel was careful, and regular viewers of this channel know that is the highest compliment I give. He pulled the archive of older plates of that same patch of sky, months and years of them, and checked his 3 new stars against history. 2 were ordinary novae. The third had a rap sheet. It appeared on plate after plate, brightening, fading, brightening again, over and over, on a cycle of about a month. It was not an explosion. It was a heartbeat. It was one of Leavitt's Cepheids, pulsing away inside the Andromeda spiral, and a Cepheid with a 31-day rhythm has a known wattage, and a known wattage plus a measured faintness equals a distance. Hubble took a red pen, crossed out the N, and wrote 3 letters with an exclamation point. VAR, for variable. That plate still exists, and that little red scrawl might be the single most important edit in the history of science, because the arithmetic that followed it was short and it was merciless. For that Cepheid to look as faint as it looked, Andromeda had to lie around 1 million light-years away, far outside even Shapley's supersized Milky Way, and later refinements would push it to 2.5 million. The smudge in Cassiopeia was not a whirlpool of nearby gas. It was another galaxy, an island universe of 1 trillion suns. And if that one spiral was a galaxy, so were the hundreds of others in the catalogues. And so were the thousands upon thousands waiting deeper in the dark, all the way down to the 3,000 crammed into Robert Williams' little deep field 72 years later. Hubble wrote the news to Shapley, who by then had moved to Harvard. A young graduate student was in the room when Shapley read the letter, and she remembered what he said as he held the page. Here is the letter that destroyed my universe. The great debate was over. 3 years late, settled by a red pen, a woman's tape measure, and a farm of glass plates. 1 human lifetime ago. We did not know other galaxies existed. That is how new tonight's question is. And notice what the discovery actually did. It took every distance we thought we understood and multiplied it by a factor that broke the imagination. The universe of 1920 was a single city of stars. The universe of 1925 was an ocean of such cities, separated by gulfs of millions of light-years. The map got bigger. The stuff did not. And that trade, more room, same furniture, is the engine of every strange fact I will show you tonight. Because Hubble's plate tells us how far the galaxies are, it cannot tell us what a galaxy is like on the inside, how tightly its stars are really packed, how much of that beautiful spiral is furniture and how much is floor. For that, we do not need a bigger telescope. We need a smaller sun. In fact, we need the smallest sun I have ever asked you to imagine. And I want you to hold it in the palm of your hand, in the middle of Times Square. Regular viewers know how this channel handles numbers too big to feel. We shrink them until they fit inside a landscape, you know. And then we take a walk. We have parked a basketball sun in Central Park before. Tonight the basketball is not small enough. Nowhere near. So we are going to perform the most extreme shrink in this channel's history. Take the sun, 865,000 miles across. A fire so large that 1 million Earths would rattle around inside it, and crush it down to a single grain of sand. 1 millimeter. Set that grain on the tip of your finger and stand with me in the middle of Times Square. Right on the red steps. Tourists streaming past. Screens blazing overhead. Everything the sun truly is. Every sunspot. Every flare. The furnace that lights every day of every life ever lived, is now a pale fleck on your fingertip, and nobody walking past even sees it. Now build the solar system around it. Earth, at this scale, is a speck of dust, 9,000ths of a millimeter wide, hovering about 4 inches from the grain. 4 inches. Everything you love fits inside those 4 inches. Jupiter, the giant, is a fine grain of powder about 20 inches out. And Neptune, the outermost planet, The official edge of the planetary family orbits about 10 feet from your fingertip. Picture that. The entire solar system out to Neptune. The whole territory it took our species 60 years of spaceflight to explore is a disk 20 feet wide, and it fits inside a New York studio apartment with room left over for the couch. So here is the question this chapter exists to ask. If the sun is this grain of sand on your fingertip in Times Square, where is the next grain? Where is Proxima Centauri, our closest neighbouring star? The very first stop on any journey into the galaxy. Take a guess before I tell you. People guess across the room. People guess down the block. Maybe Bryant Park. Maybe Macy's at Herald Square. Long-time viewers, trained on nights like the Oort cloud, guess bigger and say the far side of Central Park. Start walking and I will tell you when to stop. Out of Times Square, west on 42nd Street, into the Lincoln Tunnel, under the Hudson River. Keep going, out through the meadowlands of New Jersey, past the swamps and the power lines and the turnpike traffic. Keep going, past MetLife Stadium, where the Giants play. Keep going, through Newark, past Newark Airport, past the container ports, out beyond the reach of the subway map entirely, and somewhere around 18 miles from Times Square, in some quiet suburban town deep in New Jersey, you can finally stop, kneel down on the sidewalk, and place a second grain, smaller than the first, actually a reddish fleck, barely a fifth of a millimetre, because Proxima is a dim red dwarf. There it is, the nearest star, one grain of sand on a fingertip in Times Square, the next grain on a sidewalk 18 miles away in New Jersey, and in between, along that entire walk, through the tunnel, over the swamps, past the stadium and the airport, and mile after mile after mile of highway. Nothing. That is not a poetic nothing. At this scale, the space between the two grains contains a few stray dust motes at most. The comets and the drifting debris we met on other nights. And otherwise it is simply empty road. 4 to 6 hours of steady walking with the entire inventory of both star systems already behind you or still ahead of you. Our scoreboard opens tonight with that image. And I want it written the way a scoreboard should be. 1 grain of sand. 18 miles of nothing. Remember the number. Because unlike the falling numbers of other nights, this one is going to move in both directions before we are done. And where it finally bottoms out is where I pay the second debt from the opening of this video. 2 more grains. Quickly, to prove the first pair was no fluke. Sirius, the brightest star in Earth's night sky. The dazzling blue diamond in the winter sky over every American backyard. It looks close. It looks like a neighbour leaning over the fence. On our scale, Sirius is a grain sitting roughly 35 miles from Times Square, somewhere past Morristown, New Jersey, and Betelgeuse, the red shoulder of Orion, one of the most famous stars alive, sits not in New Jersey at all, but more than 2,000 miles away, a grain of sand lying in the desert outside Los Angeles. The winter constellations you can cover with one outstretched hand are, grain for grain, a scatter of sand spread across the width of a continent. Now zoom out and ask about the whole galaxy, because this is where the shrink ray stops being fun and starts being frightening. We crush the sun by a factor of roughly 1.4 trillion to get it onto your fingertip. Surely the Milky Way, run through the same crusher, becomes something manageable. A city, a state. Run the arithmetic. At grain of sand scale, the Milky Way's disk of stars is still about 420,000 miles across. That is not a typo, and I will say it again slowly. Shrink the sun to a grain of sand, and our galaxy is still nearly twice as wide as the real distance from the real Earth to the real Moon. You could hand every human being alive a grain of sand. Let all 8 billion of us scatter them across a sphere wider than the Moon's orbit, and we would still be more than 90 billion grains short of finishing the model. That is what a galaxy is. That is what those gorgeous packed photographs from Chapter 2 are actually pictures of. A volume too large to fit between the Earth and the Moon, even after you compress every star in it a billionfold. Sprinkled with grains of sand that sit, on average, whole New Jerseys apart from one another. And I can hear the objection, because I would raise it too. Fine, the stars are far apart, but there are so many of them. 100 billion stars, maybe several 100 billion in the Milky Way alone. 100 billion of anything sounds like enough to fill any container you hand it. It sounds like a crowd. It sounds like it should glow wall to wall like the photographs promise. So in the next chapter, we are going to do something this channel has done only once before. On the night we shrank the Oort cloud, we are going to take everything, all 100 billion suns at once, gather every star in the Milky Way into a single pile, and measure the pile against its container. The arithmetic takes 1 minute. Your intuition will not survive it. Let me start by being fair to your intuition, because it deserves a fair fight before I take it apart. 100 billion stars. Some counts for the Milky Way run to 200 billion, even 400 billion. But take the low end and just try to feel 100 billion of anything. Count them out loud. 1 star every second. No sleeping. No eating. No stopping. And the job takes you more than 3,000 years. Start counting tonight, and you finish around the year 5200. Or make it physical. Pour 100 billion grains of rice into a pile, and the pile fills a high school gymnasium roughly to the rafters. Stand on the bleachers looking at that. An entire building packed with rice. Every grain a sun. Many of those suns with their own families of worlds. Everything in you says that has to be a crowd. Everything in you says spread that through the sky and it should glow wall to wall. Exactly like the photographs promise. So let's run the experiment your gut is begging for. Tonight, we hold the great galactic roundup. We are going to gather every star in the Milky Way. All of them. The giants and the dwarfs. The newborns and the dying. Herd all 100 billion into one place, and pack them together into a single solid ball, shoulder to shoulder, no gaps. Then we measure the ball against the galaxy it came from, and we find out, once and for all, how much of a galaxy is furniture and how much is empty floor. Be generous in the packing. Count every star as a full-size sun, even though most stars are red dwarfs, far smaller. So the real answer is even more extreme than the one I'm about to give you. Crush the whole population together and the arithmetic hands you a sphere. And here is its size. The ball of every star in the Milky Way is about as wide as the orbit of Neptune. I need you to hear that clearly, because it is one of the strangest sentences this channel has ever asked me to read. Take our solar system, the 20-foot disk from last chapter, the studio apartment, the entire stellar population of the galaxy, 100 billion suns packed solid, fits inside it, every star from every constellation, every star in every photograph, every star that has ever twinkled over every campfire in human history, squeezed together, would sit comfortably inside the boundary of our own planetary system, with the Kuiper belt untouched around it. The furniture of 100,000 light-years of galaxy collapses into one ball that light could cross in about 8 hours, or say it in Times Square. On our grain of sand scale, we scattered 100 billion grains across a sphere wider than the moon's orbit. Whole New Jerseys of walking between each grain and its neighbour. Now sweep the model. Walk the 420,000-mile width of it with a broom. Gather every last grain from every sidewalk in every scaled-up New Jersey, and pour them into one pile in the middle of Times Square. The pile of every star in the Milky Way is a heap of sand, about 15 feet across. It would fit in the bed of 2 pickup trucks. The container it came from would not fit between the Earth and the Moon. Divide the ball by the container, and you get the number of the night. The density of a galaxy. the honest ratio of stuff to space. The stars of the Milky Way, all of them together, take up roughly 1 part in 10,000 billion of the galaxy's volume. That number will not stay in your head. Numbers like that never do. So here it is, one more time, dressed in water. If the volume of our galaxy were an Olympic swimming pool, the combined volume of every star in it would be smaller than a single bacterium floating in that pool. One invisible microbe. In 2.5 million litres of water. The rest is the pool. 100 billion lamps can light a continent. Spread them through a volume measured in tens of thousands of light years. And darkness wins almost everywhere. Forever. That is not a flaw in the lamps. It is the tyranny of volume. The same cube law that ambushed us on the night we measured the Oort cloud. Because volume grows with the cube of distance. And the cube law eats crowds for breakfast, double the size of a box, and you need 8 times the furniture to keep it feeling full. A galaxy is a box that has been doubled and doubled and doubled until even 100 billion suns rattle around inside it like a single microbe in a swimming pool. And now the collision from Chapter 1 stops being a miracle and becomes simple bookkeeping. Fly one swimming pool through another swimming pool and ask how likely it is that microbe number 1 strikes microbe number 2. That is a galactic merger. The gravity of the pools tangles and swirls. Oh yes, the water itself feels everything. And hold that thought, because it matters later tonight. But the microbes, the stars, sail past one another with room to spare 1 trillion times over. Andromeda can drive straight through our living room and never touch the furniture. Because statistically speaking, there is no furniture. Take one breath before we move on, because this is the bottom of the first staircase. The photographs lied about the crowding. The distances are New Jerseys between sand grains. The furniture fits in 2 pickup trucks. When someone tells you a galaxy contains 100 billion stars, they are telling you the truth. And when I tell you a galaxy is almost perfectly empty, I am telling you the same truth. Because 100 billion of anything disappears when the room is big enough. The room is that big, but if all of that is true, you are now entitled to be bothered by something. And I hope you already are. Walk back outside. Look up at the darkness between the stars. All that black we have just spent 3 chapters certifying. In a universe stuffed with hundreds of billions of galaxies, each hauling its 100 billion suns. Why is there any darkness up there at all? Point your eye in any direction. Shouldn't your line of sight, travelling far enough, eventually run into the face of some star? Somewhere, the way a line of sight in a deep forest always ends on a tree trunk. Add up all the stars behind the stars behind the stars, and the whole night sky should blaze like noon. That question has a name, and it stumped some of the greatest scientists who ever lived. Kepler lost sleep over it 400 years ago, and the first person to publish the right answer was not an astronomer at all. He was a poot, an American, broke, freshly widowed, with about 20 months left to live, standing in front of 60 confused people in a New York library on a snowy night in February of 1848, insisting that the strange little book he was reading from was the greatest thing he had ever written. His name was Edgar Allan Poe. By February of 1848, Edgar Allan Poe was one of the most famous writers in America and one of the poorest. The Raven had made him a household name 3 years earlier and paid him, by most accounts, about $9. His young wife, Virginia, had died of tuberculosis the winter before, in a cold cottage in the Bronx, and something in Poe had cracked and rearranged. He stopped writing horror. He stopped writing detectives. He spent his nights pacing under the stars. And what came out of those nights was a book-length essay about the birth and death of the universe, which he called Eureka. He told his publisher it was the most important thing he had ever done, and asked for a first printing of 50,000 copies. The publisher printed 500. On the night of February 3rd, He previewed it with a lecture at the Society Library in New York. A winter storm kept the crowd down to about 60 people, and those 60 got more than they bargained for. A gaunt man in a worn black coat talking for over 2 hours about gravity, nebulae, and the fate of all matter. The reviews were polite and puzzled. Behind his back, the verdict was harsher. The poet had lost his mind. Tucked inside that strange, feverish book is a passage about a puzzle that had been quietly embarrassing astronomy for more than 2 centuries. And to feel the puzzle, come stand in a forest with me. Make it a big one. One of those endless pine plantations in the Georgia flatlands, or the deep national forest country of northern Wisconsin. Trees in every direction. No edges. Stand anywhere in it and look out horizontally. Any direction you like. Near you. Plenty of gaps between the trunks. But your line of sight travels on through those gaps. Deeper and deeper. And somewhere out there, 10 rows back or 100 rows back, every single gap eventually closes. In a forest that goes on far enough, every possible sightline ends on wood. You cannot draw a line from your eye out of the forest. The forest, from inside, is a solid wall of trees in every direction. Now trade the trees for stars. In Poe's day, the standard picture of the universe was simple and grand. Space went on forever. It had existed forever, and it was sprinkled with stars more or less evenly throughout. And the forest logic wrecks that picture on contact. If the universe is infinite and eternal and full of stars, then every sightline from your eye, extended far enough, must eventually land on the surface of some star. Faraway stars look dimmer. Yes, but there are more of them at every greater distance, and the two effects cancel exactly. Follow the logic where it insists on going, and the entire night sky, every point of it, should be as bright as the face of the sun. No black, no constellations, just a ceiling of solid starlight, day and night, hot enough to boil the oceans. Look up tonight. The sky is dark, gloriously, obviously dark, and that darkness, which every human being who ever lived has taken completely for granted, is a flat contradiction of an infinite, eternal, star-filled universe. Something in that picture has to be wrong. The puzzle carries the name of Heinrich Olbers, a physician in the German city of Bremen who doctored patients by day, watched the sky from his rooftop by night, and wrote the problem up in 1823. But it is older than him. Kepler ran into it 200 years earlier, and it rattled him so badly that he used it as proof the universe must be finite. A walled garden with darkness beyond the wall. Others blamed clouds of dust for soaking up the distant light. And that answer fails. Because dust bathed in infinite starlight for infinite time heats up until it glows like the stars themselves. The paradox shrugged off every attack for 2 centuries. The night sky was a crime scene, and the missing light was the mystery. Here is what Poe wrote in Eureka, and I am going to stay close to his own words, because they deserve it. He said the only way we could understand the voids between the stars would be by supposing the distance of the invisible background so immense that no ray from it has yet been able to reach us at all. Read that again slowly, because a poet with no telescope and no mathematics just solved the puzzle. In 1848, no ray from it has yet been able to reach us. Yet, the whole answer lives inside that word. Light is fast, but it is not instant. We have known that since the 1600s, and if light takes time to travel, then looking far away means looking into the past. If the universe is not eternal, if it had a birth, a first morning, then there is a hard limit on how much past there is to look into. The forest logic assumed infinite rows of trees, but if the forest was planted on a specific day, then beyond a certain depth, in every direction, there are no trees yet, only bare ground where trees have not had time to grow. That is why the gaps never close. That is where the darkness comes from. The night sky is black because the universe is young, and most of the light that will someday fill our sky is still on the road, and has been since before it existed. Every patch of blackness over your backyard is a place where the mail simply has not arrived. It took physics the better part of a century to catch up to the guess. Today, we know the universe had its first morning about 13.8 billion years ago, and 13.8 billion years buys light only so much road. Stars have finite lives. 2. So even the patient sightlines eventually watch their targets burn out, and the expansion of space stretches the oldest light on the road until human eyes could not see it anyway. Modern cosmology dresses the answer in equations, and under the equations, the heart of it is still Poe's sentence. The darkness between the stars is not an absence. It is unfinished delivery, and now watch what this does to our night. Because the poet just handed us the second half of our title. Why is a galaxy so dark inside, when it holds 100 billion suns? Chapters 4 and 5 gave us reason number 1. The stars are unthinkably small compared to the spaces between them. Sand grains a New Jersey apart, a bacterium in a swimming pool. Poe gives us the deeper layer underneath, even the whole rest of the universe, pouring its light into our sky from every direction, cannot fill the gaps, because the universe has not been shining long enough. The emptiness we are exploring tonight is not just a fact about space. It is a fact about time. The darkness over your house is the youth of the universe, visible to the naked eye. Poe never saw any of it confirmed. Eureka sold a few hundred copies and bewildered nearly everyone who opened it. 20 months after that snowy lecture, in October of 1849, he was found delirious on a Baltimore street in clothes that were not his, and he died days later at age 40, still telling the few who would listen that Eureka would outlive everything else he wrote. On the darkness question, against 2 centuries of professional astronomy, the broke poet was right. So the darkness is real. It is measured, and it is ancient. We things and still living. We know why nothing fills them, we know why nothing fills them. What we have not done yet is stand in one. It is time to go home. And I mean that precisely. In the next chapter, I am taking you to our own address in the Milky Way, the quiet road where our sun actually lives, because you live in the galactic suburbs, and you are about to find out that in 4.5 billion years on this street, we have almost never had a single visitor knock on the door. We have spent 3 chapters in Times Square, a Washington auditorium, and a snowbound New York library. It is time to go home. And tonight, for the first time on this channel, I can give you a proper home address. You live in the Milky Way galaxy, on a minor spiral arm called the Orion Spur, a quiet side street running between 2 of the grand avenues of the galaxy, about 26,000 light-years out from the centre. That is not downtown. That is not the edge. That is the suburbs. Roughly halfway out the disk, where the traffic thins and the houses sit far apart, and our whole family, the sun and every world it owns, is one porch light on that street, gliding along at about 500,000 miles per hour and still needing well over 200 million years to make a single lap around the block. Let's take the census of the neighbourhood, because you have never actually met the neighbours, and there are fewer of them than you think. Draw a sphere around the sun 10 light-years in radius, on the grain of sand scale. That is a bubble more than 80 miles wide, centred on your fingertip in Times Square, big enough to swallow most of Connecticut. Inside that entire bubble, the total number of star systems is about 10, a dozen grains of sand, most of them dim red dwarfs too faint for any naked eye on Earth, scattered through a volume of space you measure in states. That is a galactic suburb, silence with a porch light every few counties, and every one of those porch lights, we learned on another night, owns an enormous yard. Long-time viewers remember the evening we devoted to the Oort cloud, the swarm of frozen comets that belongs to our sun. stretching out to something like a light year and a half in every direction. All of it inside the fence line of the sun's gravity. Hold that picture next to tonight's census and the suburb gets stranger. If our fence runs a light year and a half deep, and Alpha Centauri sits 4¼ light years away with a fence of its own, then the 2 yards very nearly touch. The properties are vast and adjoining. It is the houses that are absurdly far apart. Tiny bright homesteads lost in the middle of estates the size of the gap between stars. When you ask why the galaxy is so empty, part of the honest answer is that it is not empty at all in the legal sense. It is fully owned. Every cubic mile of that darkness is deeded to some star. It is simply that the owners built very small and very far from the road. So here is the question that tells you what kind of street you really live on. In 4.5 billion years, how many times has anybody come up the driveway? Astronomers can answer that now. And the answer is the loneliest number of the night so far. On average, a star passes within about 3 light years of the sun once every 100,000 years or so. Once every 100,000 years, somebody walks past the end of the yard. All of recorded human history. Every pyramid, every empire, every book ever written fits inside 5,000 years. And in all of it, nobody has knocked. No star has swung close enough to shine as a strange new beacon over any city humans have ever built. Every night sky in every history book is the same quiet street with the same distant porch lights. But go back further, before the books, and there was a visitor. Long-time viewers have met this stranger before, and tonight the stranger gets the fuller story it deserves. In 2013, an astronomer in Potsdam, Germany named Ralf Dieter Scholz was combing through sky survey data when he noticed a dim red point with a very odd resume. It sat about 20 light years away, and it was barely drifting against the background sky at all. Yet its light was strongly shifted, meaning it was moving fast. There is only one way an object moves fast without appearing to drift sideways. It is coming almost straight at you, or going almost straight away. This one was receding, and when a team led by the astronomer Erich Mamajek ran its trajectory backward like detectives rewinding security footage, the path led right through our front yard, about 70,000 years ago. That little star, a faint red dwarf dragging an even fainter companion, passed within roughly 4/5 of a light year of the sun, inside the fence, through the outer Oort cloud itself, wading through our sun's own comet swarm on its way past. Now put people under that sky, because there were people 70,000 years ago. Humans were alive in Africa and beyond. Ice Age, hunters sheltering from the cold, watching the same constellations you can find tonight, give or take some slow drift. Here is the detail I cannot let go of. Scholz's star was probably too dim for them to see. A red dwarf that faint hides from the naked eye, even at that range. But small red dwarfs are flare stars. Every so often they erupt, brightening 100-fold in minutes, which means that on some random Ice Age night, the closest stellar visitor our species has ever had may have flickered into view for an hour. One faint new ember low in the sky, seen by a few cold hunters who could not have known they were the only human beings in 100,000 years to catch a neighbour at the fence. Then it faded, and the street went quiet again, and it has been quiet ever since. It will not stay quiet forever. The next appointment is already on the calendar, and we met it on the Oort cloud night. A small orange star called Gliese 710 is currently about 60 light years away and closing, aimed almost dead at us. In roughly 1.3 million years it will not just brush the fence. It will come deep into the yard, plunging to around 10,000 astronomical units, far inside the Oort cloud, closer than any star we know of has come in the age of humanity. For a while, or descendant, if we have any, we will look up at a sky containing something no human eye has ever seen. A genuinely close star, blazing brighter than almost anything else up there, and visibly crawling against the constellations year by year. and its gravity will rake through the comet swarm as it goes, shaking loose a slow-motion rain of icebergs that will keep falling toward the inner solar system for millions of years after the visitor has moved on. One house call every geological era, and the guest rearranges the garden on the way out. That is life in the galactic suburbs. A dozen neighbours in 80 miles of model. One walker past the yard every 100 millennia. One real visitor since before our species could write. Now hold that quiet in your mind, because I want to show you its opposite. Our street is not the only kind of street in the Milky Way. There is a downtown, 26,000 light years from here, straight toward the constellation Sagittarius. And in the next chapter, we are taking the grain of sand there. Bring sunglasses. It is a part of the galaxy where night never quite manages to fall. Every clear summer night, from any dark field in America, you can look at downtown without knowing it. Face south in July or August. Find the constellation Sagittarius, the one that looks exactly like a teapot, and notice that the Milky Way's band glows thickest and brightest right above its spout. Like steam. That steam is the galactic bulge. You are looking 26,000 light years down the road, straight at the crowded heart of our galaxy, and the only reason it does not blind you is a wall of interstellar dust standing in the way, which is a story for the next chapter. Tonight, we are going around the wall. We are going to stand there. So pick up the grain of sand and travel, 26,000 light years inward, past arm after spiral arm. The porch lights growing steadily denser outside the windows, until we set our fleck of sand down on the sidewalk of the central bulge and look around for the neighbours. In our suburb, remember, the next grain sat 18 miles away, in New Jersey. Here, the scoreboard changes for the first time tonight. In the bulge, the grains sit a few miles apart, then closer, pushed toward the inner regions, and the typical gap falls to a couple of miles. Then below it, in the crowded pockets near the centre, where NASA estimates the stars are packed as much as 1,000,000 times more densely than on our street, the spacing drops to a few hundred feet. Read the scoreboard again, because the whole night lives in that update. In the suburbs, one grain of sand. 18 miles of nothing. Downtown, one grain of sand. 3 blocks up Broadway. Now stand on a world in that neighbourhood and look up, because this is one of the great skies the universe has on offer. Forget our night. With its few thousand faint stars, this sky carries hundreds of thousands of stars bright enough to see, and dozens upon dozens of them outshine anything in Earth's sky short of the moon. There is no true darkness here. When the sun of this world sets, the sky settles into a permanent silver twilight, bright enough to read a book at midnight, bright enough to walk without a lamp, and no creature that evolved here would ever invent the lamp, because no creature here has ever seen the dark. And here is the trade, and it is a cruel one for curious minds. Nobody standing on that world has ever seen the rest of the universe. The blaze of their own neighbourhood washes out everything beyond it. New smudge in Cassiopeia, no deep field, a sky full of stars, and every one of them local, a ceiling of streetlights hiding the ocean we found in Chapter 2. The centre of downtown has a resident, and for once on this channel it is not a star. Buried at the exact heart of all that light sits Sagittarius A star, a black hole weighing about 4 million suns, and we know its weight because we have watched the neighbours run circles around it. Since the early 1990s, 2 rival teams, one in Germany under Reinhard Genzel, one at UCLA under Andrea Ghez, kept their telescopes locked on the innermost stars year after year after year, plotting positions the way Bessel plotted his ledger, and they watched something no human had ever seen. Whole stellar orbits, completed within a career. One star, catalogued as S2, swings around the black hole once every 16 years. and at the bottom of its dive it passes within about 4 times the distance from our Sun to Neptune, moving at roughly 17 million miles per hour, between 2 and 3% of the speed of light. A star the size of ours, whipping through a turn tighter than a planetary system, around a drain of 4 million suns. That work earned Genzel and Gez the Nobel Prize in 2020, and it tells you what the deep downtown is like. It is the one place in the galaxy where the word crowded starts earning its pay, because now I have to be the accountant again. And this is the discipline that separates a true picture from a thrilling one. Even here, even 3 blocks apart, the grains of sand do not touch. Run the honest ratio. A gap of a few hundred feet between millimeter grains is still a gap hundreds of thousands of times wider than the grains themselves. Scale it back up, and a star sitting 4/100ths of a light year from its neighbour is still separated from that neighbour by more than 2,000 times the width of our entire planetary orbit. The most jam-packed stellar neighbourhood in the Milky Way, a place 1,000,000 times denser than our street, is still, by any standard a human body understands, almost perfect emptiness. 2 grains of sand, 3 blocks apart, in a city otherwise made of air. The galactic centre is crowded only by the standards of a galaxy. Nothing in it is crowded by the standards of anything on Earth. It is a rougher neighbourhood. Though, and I want that on the record for later tonight, pack stars 1,000,000 times closer, and everything we treasured about the suburbs runs backward. Strangers pass the fence constantly. Yards get trampled. Comet swarms get raked and stripped. Planetary orbits get rattled by every passing porch light. And when one of the big neighbours dies in a supernova, everyone on the block feels it. Hold that thought in your back pocket. Near the end of the night, it becomes the key to why you should be grateful. Every single morning. For 18 boring miles of New Jersey. And hold one more thing. Feel how far the scoreboard has travelled already. From 18 miles down to 3 city blocks. And notice the itch that number leaves. If the grains can get this close, how close can they get? Is there anywhere in the galaxy, any street, any address, where the grains stop keeping their distance entirely, where the rule this whole night stands on finally gives way? It is not downtown. It is somewhere stranger than downtown. And I made you a promise about it in the first minutes of this video. We are not ready for it yet, but the scoreboard is falling, and we are getting closer, and so are the grains. First, though, a confession. For 8 chapters, I have called the space between the stars nothing. Empty road, empty floor, empty miles of New Jersey. That was a useful lie. And its time is up. Hold up your fist, anywhere you are sitting. Right now, in the space between the stars, a volume the size of your fist holds a few hundred atoms. And I know how close that sounds to nothing, but the galaxy owns a lot of fists. Multiply that whisper of matter by 100,000 light years, and it adds up to an invisible ocean weighing billions of suns. An ocean that soaks every mile of the road, hides entire constellations behind veils of soot, and holds the raw material for every star that will ever be born. The darkness has a census. It is time to take it. The man who taught us what the darkness is made of never finished grade school, and he learned his trade pointing cameras at strangers in Nashville, Tennessee. Edward Emerson Barnard was born poor in 1857. 2 months after his father died. At 9 years old, he went to work in a photography gallery downtown. And his job, hour after hour, day after day, was to stand on the roof and keep a big solar camera aimed at the sun as it crawled across the sky. A human clock drive, 9 years old, tracking the brightest star there is. He fell in love with the sky from that roof, taught himself astronomy at night out of borrowed books, and started hunting comets with a small telescope. because a patent medicine tycoon was paying $200 in gold for every new comet an American discovered. Barnard found comet after comet and paid off a little house for his mother with the prize money. The neighbours called it the Comet House. By the 1890s, the photography boy from Nashville had become one of the greatest observers alive, and when he aimed the new wide-field cameras at the Milky Way itself, he photographed something that would bother him for the rest of his life. The pictures showed the great river of stars, millions of them, and running through that river, holes, black gaps, black channels, black blots where the stars simply stopped. Some were small and sharp, like bullet wounds in the sky. Some were vast winding canyons of dark. Astronomers had noticed such spots before. A century earlier, William Herschel, sweeping his telescope through a starless patch, is said to have exclaimed that here, truly, was a hole in the heavens. That was the standard reading. The dark places were tunnels, gaps in the star clouds where your sightline shot clean through the galaxy and out into the emptiness beyond. Barnard could not make himself believe it, and he could not disprove it, and the question gnawed at him for 30 years. Real tunnels through a galaxy of scattered stars should be ragged and random. His dark markings had structure. They had edges, wisps, tendrils. They connected to one another like weather. Some of them sat directly in front of glowing nebulae, plainly between us and the light. By 1919, after decades of photographs, he published his verdict along with a catalogue of hundreds of dark objects. And the verdict rewrote the sky. The holes were not holes. They were clouds. Something dark. Something enormous. Something physically real was hanging in front of the stars and blotting them out. The way smoke blots out city lights. The empty places were not empty. They were full of something we could not see. You can check his work yourself. Tonight, with no telescope, find the Milky Way from any dark American sky in summer, and look at the band closely. It is not one river, running down its middle, from the Northern Cross all the way south toward the teapot of Sagittarius. The river splits around a long, dark channel, as if someone dragged a sooty thumb through the glow. Astronomers call it the Great Rift. It is a chain of Barnard's clouds, hundreds of light years of them, hanging a few thousand light years from your porch. The ancient people of the Andes saw those dark shapes and did something no other culture thought to do. They built constellations out of the blackness itself. A llama, a fox, a serpent, drawn not in stars but in the soot between stars. They were reading the sky more honestly than Europe did for centuries. The dark shapes are things, and this is the wall I promised you in the last chapter. The reason the blazing downtown of our galaxy does not dominate our summer nights is that Barnard's soot stands in the way. The visible light from the galactic centre is dimmed on its way to us by a factor of roughly 1 trillion. For every trillion photons of ordinary light that leave the core aimed at your eye, about 1 survives the smoke. We only ever met our own downtown by cheating. With infrared light and radio waves, colours that slip between the soot grains, the most spectacular sight in the Milky Way is hidden from every naked eye on Earth by an ocean of smoke. And it is time to measure that ocean properly. Hold up your fist again, in the space between the stars, on our quiet suburban street. A volume the size of your fist contains a few hundred atoms. I want to build the ladder so you feel how close to nothing that is. That same fist, filled with the air you are breathing right now, holds about 10 billion trillion molecules, the finest vacuum chambers ever built on Earth. The ones physicists spend fortunes pumping down still hold thousands of times more matter per fist than the space between the stars. A starship crossing that ocean would feel no breeze, no drag worth the name. By every instinct your body owns, it is nothing, but the galaxy owns a lot of fists. Take that whisper, a few hundred atoms per fist, and multiply it across a disk 100,000 light years wide, and the nothing adds up to something staggering. The thin gas between the stars of the Milky Way weighs in at billions of suns. By most counts, around 10 billion suns worth of matter, hiding in plain darkness. Sweep the whole galaxy, and the invisible ocean outweighs every planet, every comet, every asteroid, every world, combined, many times over. After the stars themselves, it is the single biggest thing a galaxy owns, and it is not one ocean. It is a layered sea, and every layer has its own weather. There are the cold fogs, vast banks of hydrogen atoms drifting for centuries between collisions, so cold they sit within a few degrees of absolute zero. There is the soot itself, Barnard smoke, microscopic grains 1,000 times finer than beach sand, forged in the death throes of old stars. And though the grains make up barely 1/100th of the ocean's mass, they are what paint the Great Rift black. There are the fires. Wherever a giant star dies, its supernova blast inflates a bubble of plasma at millions of degrees, thinner than the fog around it, but seething hot. And these bubbles stack and merge until the galaxy's gas looks, on the largest maps, like the foam in a glass more than like a still sea. Here is the detail that should raise the hair on your arm. We live inside one. Our sun is currently drifting through a cavity called the local bubble, 1,000 light-years wide, blown clear by a string of supernovae that detonated over the last 10 or 20 million years. The quiet street from Chapter 7 sits inside the cooling crater of dead stars. Threading through all of it run magnetic fields, each one absurdly weak, millions of times feebler than a refrigerator magnet, but stretched across thousands of light-years, herding the charged gas along invisible rails. And through everything, in every direction, flies the sleet, the galactic cosmic rays, atomic nuclei thrown out of exploding stars at nearly the speed of light. Long-time viewers crossed that sleet with me on the night we spent 1 light-year from home. Tonight you learn where it lives. It lives everywhere. It is the rain that never stops falling inside the ocean that never moves. So the census of the darkness comes back, and the darkness is a world, a freezing, glowing, smoking, magnetized, radioactive ocean, tens of trillions of times thinner than air, heavier than 10 billion suns. And one more thing, the thing that makes it matter more than everything else in this chapter. Every star in the sky was born from this ocean. A star is what happens when some patch of that thin cold fog loses its balance and falls in on itself, and every dying star pours its ashes back into the sea for the next generation to use. The ocean is not scenery between the stars. It is the womb of the stars, and their grave, and the iron in your blood and the calcium in your bones spent millions of years drifting in it, as a few hundred atoms per fist, before the sun was ever lit, which hands us a question sharp enough to cut the night in half. Gravity never sleeps. It has had 13 billion years to work on this ocean, 10 billion suns of raw material, every atom pulling on every other atom, all night, every night, since before the Earth existed. Run that forward in your head and the galaxy has no excuse. Every cloud should have collapsed. Every atom should have been swallowed into some star ages ago. The ocean should be gone, spent, converted, 100% furniture and no floor. It is not. After 13 billion years, the sea is still mostly sea. Somebody in this galaxy has been sabotaging gravity since the beginning of time, and in the next chapter, we catch all 4 of them in the act. Inside a crime scene you can see from your backyard this winter with your naked eye. This winter, any clear evening from December through February, go outside and find Orion. He is the easiest catch in the American sky. 3 bright stars in a short straight row. The belt, hanging in the south. Now look just below the belt for the sword. A dim little vertical line of 3 fainter lights. Stare at the middle one, It looks wrong. It refuses to sharpen into a point like its neighbours. It smudges. That smudge is not a star. It is the Orion Nebula, a cloud of glowing gas 24 light-years across and about 1,300 light-years away. And it is the nearest great star factory to your house. When you look at that fuzzy patch, you are watching, live, with no equipment but your own eyes, the thing this whole night has been building toward. You are watching the invisible ocean lose its balance and turn into stars, and behind the glowing smudge, invisible to your eye, hangs the real monster, the Orion Molecular Cloud, a bank of cold, dark fog, hundreds of light-years long, holding enough raw material to build a few 100,000 suns. Now here is the crime. Count what that factory actually produces. Across the whole cloud, the birth rate comes out to a trickle, a small handful of new stars in a human lifetime, and the entire Milky Way, all its factories combined, all 10 billion suns of available ocean, converts only about 3 or 4 suns worth of gas into new stars per year. 3 or 4 per year, per galaxy. Feel how absurd that is. Do the physics with gravity alone, and a cloud like Orion's should collapse catastrophically. The whole bank of fog crashing inward in about 1 million years. A blink, a rounding error on this channel. At that pace, the young Milky Way should have converted its entire ocean into stars within a few tens of millions of years and spent the following 13 billion sitting in the dark. Finished. A museum of old red suns with no gas left and no future. Instead, it is still here. Still wet. Still building. 13 billion years into a construction project that gravity says should have taken 1,000th of that time. Out of every 100 pounds of fog that gravity grabs and starts to squeeze, roughly 99 escape. The galaxy runs its star factories at about 1% efficiency, and it's kept them throttled at 1% since before the sun was born. So gravity is being robbed, continuously, everywhere, of 99% of its winnings. Tonight, we round up the 4 thieves. The first thief is chaos. The ocean does not sit still. Every cloud in it is churning. Streams of gas ploughing into streams of gas at thousands of miles per hour. Eddies inside eddies. A permanent storm with no up and no down. Gravity is a patient shepherd trying to walk a crowd of atoms through one narrow gate. And turbulence is a riot in the crowd. Before any patch of fog can finish falling inward, the storm tears it sideways, splits it, slams it into its neighbour, stirs it back into the sea. Most clouds spend their whole lives being shuffled instead of collapsing, and the shepherd has to start over, century after century, in a crowd that never calms down. The second thief is an old friend of this channel. Long-time viewers remember the night we asked why everything in the universe spins. Every planet, every star, every galaxy, all of it turning, none of it standing still. Tonight that night sends us its bill, because everything spins. Every cloud of fog in the galaxy carries spin. Lazy, invisible, but real. And spin cannot be destroyed, only concentrated. Watch a figure skater pull her arms in, and you know the rule. Shrink and you spin faster, with no exceptions written anywhere in physics. So when gravity squeezes a slowly turning cloud, the cloud whirls up, faster and faster as it shrinks, until its own rotation flings the infalling gas sideways into a spinning disk instead of letting it fall home to the centre. Gravity pulls inward, spin throws outward, and somewhere in the middle the collapse stalls. The sun fought this thief 5 billion years ago, and here is the twist worth the whole chapter. You are living on the stolen goods. The Earth, and every planet, is made of material that spin refused to let fall into the newborn sun. Planets are what the second thief leaves at the scene. The third thief is the ghost skeleton. Those feeble magnetic fields from last chapter. the ones 1,000,000 times weaker than a refrigerator magnet, thread through every cloud in the ocean like elastic tendons. And charged gas cannot cross a magnetic field line. It can only slide along one or drag the line with it. So when a cloud tries to collapse, it must bend and compress its own skeleton, and the skeleton pushes back, storing the squeeze like a drawn bow, weak as they are, stretched over light years. The fields carry enough spring to hold a cloud open against its own weight for millions of years, gravity leaning on the bars of a cage that will not quite break. And the fourth thief is the strangest, because the fourth thief is the newborn stars themselves. The moment a factory finally succeeds, the moment some knot of fog beats the storm and the spin and the cage and ignites, the new star turns on its parents. Massive newborns blaze with ultraviolet light that boils the surrounding fog, and they breathe out winds of particles that shove the nursery apart. Aim a telescope into the heart of that smudge below Orion's belt, and you can watch it happening tonight. 4 brutal young stars called the trapezium sit in the middle of the nebula, carving a glowing cavern out of their own birth cloud, evaporating the gas that would have become their siblings. The glow you see with your naked eye is the crime lit up. And when the biggest newborns die young, as massive stars do, their supernovae detonate inside what remains of the nursery and blast it back into the general sea. Remember where you live. The local bubble, our own 1,000-light-year cavity, is exactly this. A family of star factories dynamited by their own children. And the shock waves of that demolition, some astronomers argue, are still out there, squeezing new clouds into collapse at the bubble's edges. Every generation of stars smothers most of the next one, and midwifes a little of the one after that. Add the 4 thieves together and step back, because the picture that emerges is the deepest answer to our title that this night will offer. A galaxy is not a firework, burning through its fuel in one glorious flash. A galaxy is a banked fire, a bed of coals rationing itself, throttled by storm and spin and springs and its own sparks to a slow smoulder that can last for tens of billions of years. There are galaxies that lose the throttle. We can see them out there. The starbursts. Galaxies caught converting gas 100 times faster than ours, blazing like torches, and their glory is brief, because a torch that bright empties its own tank in a cosmic afternoon and goes dark for good. The Milky Way took the other road. It burns 3 suns a year and keeps the ocean. So hold the full answer as it stands at the end of chapter 10. Why is the galaxy so empty? Because the stars are sand grains, whole New Jerseys apart. Because even 100 billion of them fit in 2 pickup trucks against a room bigger than the moon's orbit. Because the universe is too young for the gaps to have filled with light. And now the deepest layer. Because the emptiness maintains itself. The thin ocean fights its own collapse, smothers its own fires, rations its own fuel, and has held that discipline for 13 billion years. The gaps between the stars are not leftover space waiting to be filled. They are the fire being banked. A galaxy stays empty for the same reason it stays alive, which leaves one piece of bookkeeping. And it feels like a formality. We have now counted everything a galaxy contains. The stars, 2 pickup trucks of sand. The ocean, 10 billion suns of fog. The soot, the bubbles, the sleet. So add it all up. Weigh the whole galaxy on paper, and then go measure the real thing spinning in the sky. And the 2 numbers should match. In the 1970s, a quiet woman in Washington, DC ran exactly that check. Over and over. Galaxy after galaxy. At a telescope men had tried to keep her away from. The numbers did not match. They did not come close. And the gap between them is the biggest unsolved mystery in physics. Sitting in the dark, holding our galaxy together. In 1938, in a row house in Washington, DC, A 10-year-old girl moved her bed against the north window of her room so she could watch the stars until she fell asleep. Her name was Vera. Night after night she noticed the same thing. The stars wheeling slowly around one fixed point in the north. The whole sky turning like a machine. And she started memorizing meteor trails so she could map them in the morning. Her father, an electrical engineer, helped her build a telescope out of a cardboard tube and a mail-order lens. It barely worked. It did not matter. Some people are captured young, and the sky had her. The world she grew up into had other plans for girls like that. A high school teacher, handing back her work, told her she would do fine in life as long as she stayed away from science. When she wrote to Princeton for a graduate school catalogue, the catalogue never came, because Princeton did not admit women to its astronomy program and would not until 1975. She went to Vassar, then Cornell, then earned her doctorate at Georgetown, taking night classes while raising small children, with her parents driving her to campus and her husband waiting in the car because the lecture halls were no place. Everyone agreed. For a young mother, her advisor was George Gamow, one of the fathers of the Big Bang Theory, and he thought her ideas were worth hearing even when the era did not. She finished her PhD in 1954, and for the next decade she did careful, quiet work while the field mostly looked past her. Then, in 1965, two things happened. Vera Rubin became the first woman formally authorized to observe at Palomar Observatory in California, home of the largest telescope on Earth, an instrument that had simply never allowed a woman on the mountain as an astronomer in her own right. The dormitory there had one legendary deficiency: no women's restroom, and it had been used for years as a kind of joke excuse. On an early visit, Rubin fixed it. She cut a piece of paper into the shape of a skirt, walked to a restroom door, and pasted the skirt onto the little stick figure on the sign. "There," she said. "Now there is a ladies' room. Problem solved. In 30 seconds. With scissors." The second thing that happened is that she got tired of fighting. Her early work on how galaxies move through the universe had landed her in the middle of loud, hostile debates. And Rubin, by her own account, wanted a problem so plain and so unfashionable that nobody would bother arguing with her about it. So she teamed up with an instrument builder named Kent Ford at the Carnegie Institution in Washington, a quiet wizard who had built a new kind of spectrograph sensitive enough to read the light of faint gas at the dim outer edges of galaxies. And together they chose the most boring project they could think of. They would measure, very precisely, how fast the great Andromeda galaxy spins. Everyone already knew what the answer would look like. That was the point. That is why it was safe. A galaxy has most of its visible weight piled up in the middle, the blazing bulge, just as our solar system has nearly all its weight in the sun. And in the solar system, the rule of motion has been gospel since Kepler. The closer you orbit the weight, the faster you fly. Mercury, hugging the sun, tears along at over 100,000 miles per hour. Neptune, way out in the cold, ambles at a third of that. Speed falls as you move outward. No exceptions. It is the signature of orbiting a central mass. And every textbook said a galaxy's stars must obey the same curve. Fast in the bright middle, slow and lazy at the faint edge. Rubin and Ford pointed their spectrograph at Andromeda and began working their way outward, point by point, night after night, reading the spin speed at each distance from the center, the same way a radar gun reads traffic. Near the middle, the speeds climbed, as expected. Then they moved outward, toward the dim edge of the disk, waiting for the numbers to start falling. The numbers did not fall. Halfway out the disk, the gas was moving just as fast as it had closer in. 3/4 of the way out, still just as fast. At the faint outer edge, where the visible galaxy dissolves into blackness, the outermost wisps they could measure were flying along at essentially the same clip as the material near the core. Plot it on graph paper and the curve of speed against distance rose from the center and then went flat. Dead flat. All the way out. Like a Kansas horizon. No fall-off. No Kepler. Rubin later said the results were so clean and so strange that at first she assumed something like this simply could not be right. So they did what careful people do. They measured more galaxies. Through the 1970s, Rubin and Ford worked their way across the sky. Spiral after spiral. Dozens of them. And every single one came back the same. Flat. 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 It is one of the eeriest results in the history of measurement. Every spiral galaxy anyone has ever clocked is spinning wrong. Feel the size of the problem. Speed at the edge is a scale that weighs everything inside. Those outer stars and gas clouds are moving so fast that the gravity of everything we can see, every star, every wisp of Barnard smoke, all 10 billion suns of invisible ocean, is nowhere near enough to hold on to them. At those speeds, the Milky Way's visible matter could no more keep its outer disk than you could keep a bowling ball on a string of sewing thread. The galaxies should be flying apart. Stars should be streaming off their rims into the void like sparks off a grinding wheel. 13 billion years is a long time to be flying apart. And yet there they are. Every one of them. Calmly holding together. Spinning like solid wheels. There are only two ways out. And both of them are terrifying. Either the law of gravity itself, Newton and Einstein both, quietly breaks when the distance is stretched to galactic size, or the scale is honest, and we are the blind ones, and every galaxy is filled with an enormous amount of matter that does not shine, does not glow, does not block light, does not show up in any photograph, and outweighs everything visible several times over. Rubin had a predecessor, and it is time to pay a 40-year-old debt. Back in 1933, a Swiss astronomer at Caltech named Fritz Zwicky had weighed a whole cluster of galaxies, the Coma cluster, by clocking how fast its member galaxies swarmed around one another, and found the same crime at a grander scale. The galaxies were moving far too fast for the visible matter to hold the cluster together, by a factor that made the audience wince. He wrote that some vast unseen component must be there, and he gave it a name that stuck: dark matter. Almost nobody followed up. Part of the reason is that the measurements were rough. Part of the reason, honestly, is that Zwicky was one of the most abrasive men in the history of science. A genius who addressed colleagues he disliked as spherical bastards. Because, he explained, they were bastards any way you looked at them. The field filed his discovery under eccentric and moved on for 4 decades. Until a polite, patient woman with a spectrograph made the same crime impossible to ignore. One flat line at a time. Run the modern books and the deficit is brutal. Weigh the Milky Way honestly, using the motions of its stars and its satellite galaxies, and the total comes out somewhere around 1.5 trillion suns. Now count what we can actually see. The 100 billion stars. 2 pickup trucks of sand. The 10 billion suns of fog and smoke. All of it together is a minor line item. Most of the galaxy, by weight, around 5 parts in 6, is something else, something that has never once registered on any camera, in any colour of light. In a century of trying, it appears to be draped around the bright disk in a vast rounded halo, far larger than the part that glows, which means the beautiful spiral in every photograph is just the lit-up sediment settled at the bottom of something much bigger and completely invisible. I owe you the discipline here, and I am going to keep it. We know how this stuff pulls. We have measured its pull in hundreds of ways. In spinning disks, in swarming clusters, in the bending of light itself. We do not know what it is. Not a hint. Despite half a century of hunting, despite detectors buried down mine shafts waiting for one whisper of a particle, It may be a sea of particles nobody has met. There is a minority of physicists who still bet the law of gravity itself is what gives at large scales. The pull is a measurement. The name dark matter is a confession dressed up as an answer. Rubin herself loved that unfinished edge. She worked into her 80s, kept her office at Carnegie, mentored 2 generations of women into the field, and answered the recurring question about a Nobel Prize by saying the prize never mattered to her. The data did. She died in December of 2016, and the debate about her missing Nobel flared exactly the way she never had. Within a few years, the great new survey observatory rising on a mountaintop in Chile was named for her. The Vera Rubin Observatory's job, in part, is to map the pull of the darkness she discovered. Stand back now and look at what this chapter did to our night, because it performed a reversal I have been setting up since chapter 3. Edwin Hubble proved the universe is millions of times bigger and emptier than anyone believed. Vera Rubin proved every galaxy in it is several times fuller than anyone can see. Both are true at once. The emptiness of a galaxy is real, measured, and fast. And the emptiness is also loaded, floor to ceiling, with a presence we can weigh but cannot name. The gaps between the sand grains are not vacant. They are the main event, which sharpens tonight's question to its finest point yet. A galaxy, we now know, is 100 billion separated grains, an ocean of fog, and an invisible halo outweighing all of it. And essentially none of these parts ever touch. On Earth, everything we build holds together by touching. So what, exactly, is a galaxy? What kind of thing keeps its shape for 13 billion years when its pieces never once make contact? There is an answer, and you can watch a small, breathtaking version of it any winter evening over the rooftops of Rome. Every winter, at dusk, the sky over Rome puts on one of the great shows in the natural world. Starlings. Hundreds of thousands of them, sometimes over 1 million, gather above the city as the light dies, and they fly together in a single cloud that behaves like a living creature. It balls up, stretches into a ribbon, splits in 2, folds back into itself, pours across the sky like smoke made of intention. Tourists stop dead on the bridges over the Tiber and just stare. The shape has edges. The shape has moods. The shape turns as one thing, and it is not one thing. There is no leader-bird. There is no blueprint. Each starling obeys a couple of simple instincts. Stay close to your 6 or 7 nearest neighbours. Match their speed. Do not collide. And out of 1 million birds running that tiny private rule, the giant creature appears. Here is the detail that earns this scene its place tonight. In all that swirling, in a cloud of 1 million bodies pulling hairpin turns at 40 miles per hour, the birds essentially never touch. The creature in the sky is real. You can photograph it, track it, watch it, hunt and flee, and it is made 100% of coordination across gaps. It is a shape with nothing solid inside it. Now you are ready for the honest answer to the question Chapter 11 left us holding. What is a galaxy? A galaxy is the largest murmuration in nature. 100 billion stars. None of them touching. None of them ever going to touch. Each one privately obeying a single simple rule. Fall toward the combined pull of everything else. That is the entire rule book. There is no frame holding the spiral together. No spokes, no rim, no glue. Every structure you have ever stood on or lived in is built by contact. Brick mortared to brick. Stone stacked on stone. Cell pressed against cell in your own body. A galaxy is built the other way, out of pure long-distance choreography. Gravity whispering across light years of Barnard's smoke and Rubin's darkness. A million New Jerseys of gap organized into one shape that has held its pose since before the Earth existed. And the shape is not sitting still. It only looks frozen because our lives are too short to catch it moving. Speed the film up and the pose dissolves into dance. So let's speed the film up. Starting with the star you know best, the Sun. Right now, tonight, is moving at about 500,000 miles per hour, carrying you and everything you love in a huge circle around the galactic center. Even at that speed, the circle is so large that one lap takes roughly 230 million years. Astronomers call it a galactic year, and it is the best clock I know for feeling what a galaxy's dance floor is like. 1 galactic year ago tonight, the Earth existed, the oceans existed, and the most advanced things walking the land were the earliest dinosaurs. The entire reign of the dinosaurs, their whole 160 million year empire, plus the asteroid, plus the age of mammals, plus yous, all of it fits inside a single lap. The Sun has made about 20 of those laps in its lifetime. 20 galactic years old. Our star. A middle-aged commuter who has driven around the block 20 times, while the passengers in the back seat went from single cells to spacecraft. The lap is not even flat. As it circles, the Sun also bobs, floating slowly up through the thin disk of the galaxy, drifting a couple of hundred light-years above the midplane, then sinking back down through it and out the other side. The whole cycle taking tens of millions of years. A dolphin arcing through a sea of stars in strokes, too slow for any species to witness even one of. Every star on the dance floor is doing its own version of this, each on its own tilted, bobbing, drifting loop, and no two loops quite alike, which means the sky over your head is temporary. The constellations feel eternal because a human lifetime is a camera flash, but every star in every constellation is a starling in mid-swerve, moving on its own private path. Give it 100,000 years. A blink on tonight's clocks, and the Big Dipper is broken, its 7 stars smeared into an unrecognizable scatter, because 5 of them are drifting one way and 2 are headed somewhere else entirely. Orion comes apart. The teapot of Sagittarius tips and spills. Every culture that ever named a constellation was naming a single frame of a film. And the film has been running for 13 billion years. Here is where your intuition will try one last defense. And it is a good one. If every star moves on its own loop, what about the spiral arms? Those grand glowing pinwheel arms are the most solid-looking things in any galaxy photograph. Surely those, at least, are structures. Rivers of stars travelling together. They are not. And the truth about them is one of my favourite facts in astronomy. The arms are traffic jams. Think of a crowded American interstate where some slowdown has formed. A wave of brake lights a mile long. Watch that jam from a news helicopter for an hour, and the jam itself barely crawls along the highway. But no car stays in it. Cars flow in at the back, creep through, and escape out the front. And the jam persists anyway. A stable shape made of constantly changing members. A spiral arm is exactly that. It is a slow-moving zone of crowding, a wave of higher density sweeping around the disk. And individual stars drive into it, pass through, and drive out the far side, over and over across the eons. The arms glow bright in photographs for a beautifully simple reason. The crowding squeezes the invisible ocean, and squeezed fog is exactly what Chapter 10 taught us to watch, because squeezed fog ignites. The arms are lined with brand new, blazing, short-lived stars, born in the pile-up, dead before they can drift far from it. The pinwheel is not a structure. It is a standing wave of stellar traffic, outlined in the light of newborns that never live long enough to leave the jam. So a galaxy keeps its shape the way a whirlpool keeps its shape. Not because anything stays, but because everything moves in order. The sun that lights your morning has crossed spiral arms and open gulfs, has bobbed above the disk and dived back through it, 20 laps of ceaseless motion, and never in 4.5 billion years has it come close enough to another star to feel so much as a nudge worth recording. That last clause deserves a second reading. 20 laps through a dance floor of 100 billion moving dancers, and never one bump. Nothing about a galaxy is still. And thanks to the emptiness we have spent all night measuring, nothing about it ever needs to collide. Chaos at every point, choreography in the whole, forever, held together by pull alone across gaps that light itself takes years to cross. That is the standing answer to what a galaxy is. And I find it changes how the photographs look. The frozen spiral becomes a snapshot of a creature mid-swerve, a million starlings caught between wing beats. But I know what has been building in the back of your mind, because it has been building in mine. All night we have measured these gaps from the outside, from armchairs, with sand grains and swimming pools and traffic reports. 18 miles of New Jersey is a number. It is not an experience. Somewhere in the last few chapters you have started to wonder what the emptiness would actually feel like. From inside, through a window, year after year. If a human being ever tried to cross it, long-time viewers know this channel owns a ship for exactly this kind of question. We have boarded it before. On the night we asked how long it takes to travel a single light year. In the next chapter, we board it again. And I have to warn you before we do, every movie you have ever seen about this voyage, every one, has lied to you about the single most important thing. Not the speed, not the danger, the view. Long-time viewers of this channel have walked this hallway before. Carpet underfoot, a ceiling, a floor. And the floor means it, because this is the one gravity starship, the most humane vehicle physics has ever sketched, pushing forward with a gentle, permanent thrust exactly as strong as Earth's own pull. On the night we asked how long it takes to travel 1 light year, this ship gave us the astonishing answers. And tonight I am not going to reopen that ledger. Tonight we board for a different reason. Tonight we ignore the clock completely and look out the window. Because every movie you have ever seen about this voyage has lied to you about the view. And I want you to see the truth with your own eyes. Year by year, here is the view the movies promised. Stars streaming past the glass like snowflakes in headlights. Glowing nebulae rolling by on the left. A ringed planet sliding past on the right. Some new wonder every few minutes. The galaxy as a scenic highway. Hold that picture up next to the scoreboard we have been keeping all night and watch it fall apart. The stars are grains of sand separated by 18 miles of New Jersey. A highway needs scenery beside the road. This road has 2 grains of sand on it, one at each end. And between them, nothing your headlights will ever find. So let's run the honest crossing. Destination Proxima Centauri. 4.25 light years. The shortest interstellar trip that exists for us. And let's keep a diary of the window. Departure day is glorious. I will give the movies that much. The Earth falls away. A blue marble. Then a blue dot. The moon slides past in the first hours. Over the following days and weeks, if our route oblige, Mars or Jupiter may swell and shrink in the glass, and the sun blazes behind us. Still a disk. Still the master of the sky. Enjoy every minute of this stretch, because this is all the scenery the entire voyage will ever offer. Within weeks the planets are gone, sunk back into the glare. Within months, the sun itself has given up its disk and hardened into what it will remain for years. Brilliant. Dimming point astern. Diary. Year 1. The window shows stars. The same stars you know from Earth. The same constellations. Orion. The Dipper. The Teapot. Unchanged. Because we have moved a few 100 billion miles and the scenery is trillions of miles away. Nothing crosses the glass. Nothing drifts by. Long-time viewers remember that even the comets out here, the icebergs of our own Oort cloud, floats so far apart that a ship could cross the entire cloud without one of them ever coming close enough to see. We are inside our sun's own yard. Chapter 7's fence, still far ahead. And the yard, from inside, is invisible. Diary, Year 5. And this is the entry that breaks the movie forever. The constellations have not changed. I want to be precise about this, because it is the loneliest fact of the crossing. We are years deep into interstellar space, moving faster than any human object has ever moved, and the sky in the window is still, to your naked eye. The exact sky over your backyard tonight. To catch any change at all, you must photograph the nearest stars and compare the plates across years, the way Bessel did. And only then does the drift show. The galaxy is so large that even light-speed travel barely moves the wallpaper. The window is not a movie screen. The window is a painting, and the painting almost never gets repainted. There is one exception, one thing in all the blackness that visibly changes, and it is behind us. The sun is falling down the rankings. Month by month it dims, from the master of the sky to merely the brightest star in it. Then to a bright star among bright stars. Somewhere in the middle years of the crossing comes a quiet, unmarked moment that I think would change every human being aboard. The day a passenger drifts to the rear window, looks for home, and cannot immediately find it. The sun, at this distance, has joined a constellation seen from Proxima. In fact, our sun appears as one more handsome star in Cassiopeia, turning the crooked W where this whole night began into a crooked zigzag of 6. Everything ever loved, every ocean, every city, every grave and every cradle, folded into one anonymous point of light in somebody else's constellation. The mother in the communications booth, on the night we spent a light year from home, was living on the far side of that moment. The crossing does not feel like travelling through the galaxy. It feels like the galaxy slowly forgetting your address, and the destination gives you almost nothing to hold on to in exchange. Here is a detail that stuns people. Proxima Centauri, our nearest neighbour, the finish line itself, is invisible. It is a red dwarf so dim that from Earth, from the departure lounge, from most of the road, no naked eye can find it at all. You spend years flying toward a point of black. Only in the final stretch does your destination condescend to appear. First to instruments, then finally to the eye, a faint ember growing in the glass. And only in the last months does it bloom into a small red sun with weather and moods, and we now believe, at least one world of its own. The arrival is real, and the arrival is beautiful. It is also the first new scenery in years. That is the honest crossing. An ocean voyage with no islands, no birds, no driftwood, no passing ships, a painting in every window, home dissolving into wallpaper astern, destination hiding ahead, and the deepest silence any human crew has ever kept. The emptiness we have measured all night with sand grains and swimming pools. This is what it does to a traveller. It removes the journey from the trip. Between the first weeks and the last months there is no middle, only duration. Only the hum of the ship and the unchanging stars and whatever the crew brought along inside their own heads. Now let that silence do its work on you for a moment, because it raises the question this chapter has been circling since the first diary entry. We built this ship in our imagination and crossed to the nearest grain of sand. But the galaxy holds 100 billion grains. And all night we have been told some of them have worlds. And the ocean of fog is seeded with the chemistry of life. Iron and carbon and water. Everywhere we look. If even a fraction of those worlds ever opened an eye, the galaxy should be full of neighbours. So why does the window stay silent? Why does the whole sky stay silent? I cannot answer that question tonight. Nobody can. Yet. But I can tell you about the one night in history when the silence may have broken. For exactly 72 seconds. over a golf course in Ohio. In the summer of 1977, in the flat farm country outside Delaware, Ohio, stood one of the strangest instruments in America. It was called Big Ear, and it looked like a drive-in movie theatre built for giants. Two great aluminum reflectors facing each other across a metal ground plane wider than 3 football fields. Big Ear was a radio telescope owned by Ohio State University, and by 1977 it had been assigned the loneliest job in science. Night after night it lay there listening for artificial radio signals from other stars, running the longest continuous search for extraterrestrial intelligence ever attempted. The university could not afford staff to sit with it, so the telescope worked alone, sweeping the sky as the Earth turned, and a computer summarized everything it heard onto printout paper, column after column of numbers, which a handful of volunteers picked up and checked every few days at their kitchen tables. One of those volunteers was a soft-spoken engineering professor named Jerry Eman. On August 19th, he sat down at home with the stack of printouts covering the past few days and began scanning down the columns the way you would proofread a phone book. The computer wrote signal strength in a simple code, digits for the quiet stuff, letters for anything loud. Each step up the alphabet meaning a stronger signal, page after page read like static reads. Ones, twos, blanks, an occasional 3. And then, in the data recorded at 11:16 at night on August 15th, Eamon's eye caught a column that climbed. 6 characters, rising steeply, peaking at the letter U, a signal 30 times louder than the background hiss of the universe, then falling away. The rise and fall lasted 72 seconds, which was precisely, the length of time a fixed point in the sky takes to drift through Big Ear's beam as the Earth rotates. Whatever this was, it was not a glitch inside the machine. It sat still among the stars while the planet turned beneath it, the signature of a source in deep space. Eamon grabbed a red pen, circled the 6 characters, and wrote one word in the margin. Wow. For the second time tonight, a red pen makes history. Hubble's plate, said Var. Eamon's printout says, wow. And that page is now preserved like a relic, because of what else was true about those 72 seconds. The signal arrived on a very particular channel, the natural broadcast frequency of hydrogen, the most abundant atom in existence. Years earlier, scientists planning the search for other civilizations had reasoned that if anyone out there wanted to be found, they would transmit near that universal frequency, the one channel every chemist in the galaxy knows by heart. The cosmic meeting place on the dial. The WOW signal landed almost exactly there. It was loud. It was clean. It was narrow in a way nature almost never manages. And it came from the direction of Sagittarius. The teapot, downtown, the crowded heart of the galaxy we visited in Chapter 8 was, give or take, the direction the shout came from. Big Ear swung back to that patch of sky the next night, and heard nothing, and the next night, nothing. Eamon and his colleagues went back more than 50 times over the following weeks. Other observatories joined across the following decades, with far more sensitive ears. The sky in that direction has never said another word. Explanations have been proposed and have wobbled. Interference from Earth reflected off space junk fits poorly with the behaviour. A pair of comets passing through the area was suggested decades later, and most radio astronomers found it unconvincing. After nearly 50 years, the honest summary is 2 sentences long. We do not know what it was. It never repeated. Now, I need to keep this channel's discipline, so let me say plainly what the WOW signal is and is not. It is not proof of anyone. One unrepeated signal proves nothing, and the astronomers who know it best say so loudest. What it is the perfect door into the real subject of this chapter. Because suppose, just as an exercise, that it had been a hello. Suppose some patient civilization on a world towards Sagittarius aimed a transmitter our way. The stars in that patch of sky sit hundreds to thousands of light years off. Their hello, if hello it was, left home while Rome ruled, or while the pyramids were young, sent by beings who could never know whether anyone would exist at the receiving end when it arrived. And if we answered tonight, our reply would land centuries or millennia from now, on a world that may long since have forgotten sending anything, or may no longer have anyone on it to remember. One exchange of greetings, one single round of "how are you?" spanning the rise and fall of entire civilizations at each end. That is not a conversation. That is correspondence between eras, messages in bottles thrown between centuries that will never meet. And this is where the emptiness we have measured all night reveals its final dimension. Because the gaps between the stars are not just gaps in space, they are gaps in time. Run the exercise generously, and I will label it clearly as an exercise, not a measurement. Grant the galaxy 1,000 talking civilizations tonight, a wildly hopeful number by any accounting. Scatter 1,000 of anything through a disk of 100 billion stars, and the arithmetic of Chapter 5 comes back around. The average distance between any two of them comes out to thousands of light years. Every question crosses in millennia. Every answer doubles it. 2 civilizations could each last 10,000 years. An eternity by human standards. Twice the age of writing. And still miss each other completely. One falling silent before the other's first shout arrives. Ships passing in a night 400 generations long. The galaxy does not need to be lifeless to be silent. Even if life were common, distance alone could keep every harbour dark. Every island convinced it is the only one in the ocean. I find that thought changes how the silence sounds. The quiet over your backyard tonight is not necessarily an empty room. It may simply be a room too large for any voice to cross while the speaker still lives. Billions of stars, and every one of them an island of silence. Not because the sea is empty, but because the sea is the size we spent 13 chapters measuring. There is a coda to the Ohio story, and I've debated whether to tell it. Because it hurts. Big Ear listened faithfully for another 2 decades after its 72 famous seconds. Then the land it sat on was sold, and in 1998, the most storied instrument in the history of the Great Silence was torn down. The reason was the golf course next door. It wanted to expand. Today, where the giant ear once lay listening for other minds across thousands of light years, there are fairways and golfers, most of whom have no idea, play through on summer evenings under the exact patch of sky the shout came from. So the emptiness isolates. That is its cost. And we have now felt that cost 3 chapters running. At the window of the ship, in the booth with the mother, on the silent channel over Ohio. It is a heavy bill, and it is time, at last, to see what the emptiness buys. In the next chapter we return to the collision this whole night opened with. Andromeda arrives. 1 trillion stars come down on our heads at 250,000 miles per hour, and the emptiness we have spent 13 chapters measuring finally gets its chance to save every single one of them. Come back to the backyard where this night began. The crooked W of Cassiopeia, the grey smudge the size of a grain of rice. I am going to hand you the next 4 billion years of that view. On the timetable the textbooks have promised for a century, compressed into a few minutes. Each night is one frame of the film. Run it for the first 100 million years. Almost nothing. The smudge brightens by amounts no eye could catch. But the film is patient, and by 500 million years in, no one could miss it. The grain of rice has become a thumbprint, then a saucer, a tilted spiral of light with visible structure, dark dust lanes, a glowing core, star clouds like distant harbour lights. By 3 billion years, Andromeda owns the sky. It spans horizon to horizon on autumn nights. A second Milky Way hung crossways over the first, so bright it cast shadows. And now the two giants begin to touch. Gravity first. The way galaxies always touch first. Both disks start to warp. Long banners of stars peel away from both rims and stream into the dark. Bridges and tails tens of thousands of light years long. The two shapes reaching for each other across the closing gap like hands. You do not have to take the film's word for any of this. Point a telescope tonight at the constellation Corvus, the little crow riding low in the southern spring sky, and you will find two galaxies some 60 million light-years away caught in exactly this act. Astronomers call them the antennae, because the streamers of stars flung off their first pass curve away like the feelers of an insect, and the Hubble images of their tangled bodies show the other thing. The thing that makes a galactic collision one of the most spectacular events the universe stages. The wreckage is on fire. Everywhere the two galaxies overlap. Space is crowded with brilliant blue knots. Thousands of newborn star clusters. A firestorm of creation running from one end of the crash to the other. Here is why. And it is the whole night's bookkeeping paying off at once. When the disks finally interpenetrate, the stars themselves ghost through. Exactly as Chapter 5 promised. Two swarms of sand grains, each grain 18 miles from its neighbours, slide through one another, and the expected number of direct hits between the general populations rounds to 0. But the invisible oceans cannot ghost. Gas is not grain. Gas is continuous. A fog fills its whole volume. And when two fogs meet at hundreds of miles per second, there is nowhere to dodge. The oceans of the two galaxies slam together head-on. Shock fronts hammer through the clouds. And that compression is precisely the trigger we studied in Chapter 10. The squeeze, the four thieves spend eternity, preventing. The collision overrules the thieves. Clouds that would have idled for another billion years are crushed past their tipping points by the thousands. And the merge system erupts into starbirth at rates our quiet galaxy has not seen since its youth. Stars almost never collide. Gas always does. That is why the film shows no impacts and yet blazes like a burning city. So put yourself on Earth, or wherever our descendants keep the family album. During the crossing itself, the night sky of the merger era is the greatest sky any inhabitant of either galaxy will ever have seen. Two galactic cores glowing like lanterns in different corners of the night. Rivers of stars arcing between them. Whole new constellations of brilliant blue clusters igniting along the shock fronts. And supernovae popping off so frequently that a patient observer might catch several in a lifetime. Bright enough to read by. And through all of it, no collision. No impacts. No stars raining down. The show is silent and slow and vast, rearranging itself over millions of years. Terror scheduled so far apart in time that no single generation would ever see anything move. What about our own grain of sand? The simulations that mapped this merger tracked the sun specifically, and its most likely fate is strange and gentle. As the two galaxies swing through one another, trading momentum, the odds favour our star being slung outward, flung to a Veda, longer orbit in the merged system's outskirts, a quieter suburb even than the one we know. There is a smaller chance, a real one, that during one of the passes, Andromeda's gravity wins the tug-of-war outright, and our sun changes citizenship. Spending an age as an Andromedan star before the final merger reunites everything anyway. Either way, the solar system itself sails on untouched. Planets steady. Comets in place. Because the emptiness that protects a star protects its yard too. And either way, whoever watches those skies will not be us in any familiar sense. Because on the same 4 billion year clock, our aging sun will have grown hot enough to have taken Earth's oceans long before the second galaxy fills the sky. The wedding comes after the house has emptied. The dance takes a long time to finish. The first pass is a miss. The two cores swinging by and climbing away from each other. Slowed by all the momentum they traded away into flung stars, they fall back. A second pass. Closer. Wilder. Tails everywhere. A third. Each plunge burns off orbital energy until, a few billion years after first contact, the two giants finally settle into each other and their cores merge, the two central black holes spiraling together into one, and the churning settles, and what remains is no longer a spiral at all. The gas is mostly spent, splurged in the great firestorms of the crossing. Starbirth gutters out. The stars of both galaxies pour into one enormous, smooth, slowly reddening ball, an elliptical galaxy, a retirement community of 1 trillion suns, and astronomers who model it have already given it a name that sounds like a joke and probably is not. Milky Way. That is the ending everyone has been promised. In every documentary, every textbook sidebar, every planetarium show of the last 100 years. And I fed you the same promise in the opening minutes of this very video. On purpose. Andromeda is coming. The blue shift is real. Slipher measured it in 1912, and it has never wavered. The collision is certain. Every version of the story agrees, except that in 2025, a team of astronomers in Finland finally did what nobody had quite done before. They checked the engagement, and it is time for me to pay the first debt of the night. Start with what Slipher's blue shift actually tells us, because the entire twist hides inside its blind spot. A blue shift measures approach, and only approach. Picture headlights on a 2-lane Texas highway at night. The lights grow brighter, so the truck is coming. That much is certain. What the brightness alone can never tell you is whether the truck is in your lane. A vehicle aimed straight at you and a vehicle about to whisk past your left shoulder both approach at full speed until the last moment. To know which one Andromeda is, you need its sideways motion, its drift across the sky. And for 100 years after Slipher, nobody could measure it, because at a distance of 2.5 million light-years, even a galaxy flying sideways at hundreds of thousands of miles per hour creeps across our sky too slowly for any instrument to catch. Then, in 2012, a team did catch it, and the story loops back to a building we already know, at the Space Telescope Science Institute in Baltimore, the same institute where Robert Williams gambled his career on an empty patch of sky. An astronomer named Roland van der Merel and his colleagues spent years photographing selected fields of Andromeda with Hubble, then photographing them again, and comparing the frames against the fixed wallpaper of far more distant galaxies in the background. The drift they were hunting is one of the smallest motions ever measured, a shift you could compare to watching a human fingernail grow. From the distance of the moon, they found it, and the number came back tiny. Andromeda's sideways motion was so small compared to its approach speed that the truck was, for all practical purposes, in our lane. NASA announced it plainly. The collision was no longer a likelihood. It was a schedule. First contact in about 4 billion years. Merger complete a couple of billion after that. The textbooks inked it in. The documentaries animated it. And Milky Way entered the language. Now, come to Helsinki. Finland. In 2025, where an astrophysicist named Till Sawala and an international team decided to stress test the schedule. They took no new pictures. They took the same measurements everyone trusted. The approach speed, the Baltimore sideways drift, the best masses for everything involved. And they did 2 honest things with them. First, they refused to ignore the error bars. Every one of those measured numbers carries an uncertainty, a plus or minus, and the old story had always run the calculation down the middle of every range. Second, and this is the heart of it, they invited the rest of the family to the wedding. The Milky Way and Andromeda do not live alone. Andromeda has a companion, the Triangulum Galaxy, the third giant of our local group, tugging on it constantly. And we have a companion of our own, the Large Magellanic Cloud, the biggest and brightest of our satellite galaxies, a smudge of light that fills the southern sky over Chile and Australia, riding along beside the Milky Way and hauling on us the whole time. The classic forecast had treated the collision as a stately dance for two. It has always been a four-body problem, so Sawala's team ran the dance the way honest bookmakers would. They simulated the next 10 billion years of the local group about 100,000 times, and in every single run they rolled the dice inside the error bars. A slightly different Andromeda mass here, a slightly different sideways drift there. Every version consistent with everything we have measured. 100,000 possible futures, all of them legal. Then they counted. In roughly half the futures, the promised story holds. The two giants spiral together and merge within 10 billion years. Milky rises. The textbooks win. And in roughly the other half, the wedding never happens. The Milky Way and Andromeda swing past each other in a vast near miss. Two dancers circling without embracing, and drift apart to circle again on orbits. So long the universe will have dimmed around them before any reunion. Split the difference, and the most famous certainty in astronomy comes out, in the team's own summary, to very close to a coin flip, and the specific version everyone grew up on. A first collision landing within the next 4 to 5 billion years, dropped in their accounting to around a 2% chance. The appointment written in every textbook of my lifetime is now. At best, Pengilet, the wrecking ball. Wonderfully, is the little one. The Large Magellanic Cloud carries only a modest fraction of our galaxy's mass. A junior partner nobody had bothered to seat at the table, but it happens to be pulling the Milky Way sideways, perpendicular to the road toward Andromeda. A small hand on the steering wheel held there for billions of years, and in run after run, that steady sideways tug is what eases the truck out of our lane and turns the head-on collision into the near miss. A satellite galaxy most people in the Northern Hemisphere have never once seen may be quietly cancelling the biggest event on our sky's calendar. Hold the discipline with me, because this is one study, and this is how science is supposed to breathe. Nothing about the measurements changed. Andromeda is still approaching at 250,000 miles per hour. Tonight, and Slipher's blue shift stands as solid as it did in 1912. What changed is our honesty about what we do not yet know, and the next data releases from the Gaia mission will tighten the sideways numbers and swing the odds one way or the other. The coin is in the air, and it will stay in the air, most likely, for the rest of our lives. Notice too what the twist does not undo. If the wedding does happen, everything in Chapter 15 still holds. The fireworks, the ghosting stars, the gentle slinging of the sun. The only thing that died in Helsinki was the word certain. And notice, finally, why this twist belongs to tonight's title. Because it is not a random piece of trivia. It is the emptiness. One more time, running the show. In a universe this sparse, gravity's ledger is delicate. There are no walls to bounce off, no friction to forgive a small error, nothing anywhere to damp the whisper of a junior galaxy's pull. So, a nudge from a companion, a fraction of our size, sustained across the silence, is enough to rewrite the destination of 1 trillion stars. Crowded systems have fates. Empty systems have negotiations. The same gaps that let two galaxies pass through each other without a single impact also mean that whether they meet at all can hinge on the smallest voice in the room. In the emptiness we have measured all night, even the future is written in pencil. One promise paid, one still on the books. All night I have told you the grains of sand never touch, and the rule has held from the suburbs to downtown, through mergers and near misses alike. So now find the southern sky, the constellation Centaurus, and look for a soft round glow that every star chart for 2,000 years listed as a single ordinary star. It is 10 million stars. It is the densest address our galaxy owns. It is 12 billion years old, and deep in its heart, the rule of this entire night finally breaks. Next chapter, we go in. For 2,000 years, the strangest object in our galaxy hid in plain sight inside a clerical error. In the 2nd century, the astronomer Ptolemy, cataloguing the sky from Alexandria, logged a modest point of light on the back of the constellation Centaurus, the Centaur, low in the southern sky. He recorded it as a star. Every chart for the next 1,500 years copied him. And in 1603, when the German mapmaker Johann Bayer assigned Greek letters to the stars, this one received a star's proper name, Omega Centaur. Then, in 1677, a 20-year-old Englishman named Edmund Halley camped on the remote South Atlantic island of St. Helena to chart the southern heavens, aimed his telescope at the old catalogued star and flagged it as something else. A small luminous patch. Fuzzy. Wrong. Refusing to sharpen. It took until the 1830s for a telescope big enough to settle the matter, when John Herschel, observing from the Cape of Good Hope, resolved the patch at last, and the star dissolved under his eyepiece into stars beyond counting. Omega Centauri is 10 million suns, 10 million of them, gathered into a single glowing ball about 150 light-years across, hanging 17,000 light-years from your porch. And it is so bright that your naked eye reads the whole swarm as one soft star, which is exactly how it fooled every astronomer from Ptolemy to the age of steam. It is the largest of the Milky Way's globular clusters, a family of nearly 200 ancient star swarms that orbit our galaxy the way bees orbit a hive, each one about 12 billion years old, relics from before the galaxy's disk existed. And Omega Centauri is strange even among its own kind. So heavy, so complicated in its chemistry, that many astronomers argue it is a survivor with a stolen past. The naked core of a small galaxy, the young Milky Way caught and devoured. Its outer stars stripped away. Its dense heart still orbiting the thief. Now run tonight's census on it, because this is the address the whole scoreboard has been falling toward. 10 million stars in a ball 150 light-years wide. Compare that to home. In Chapter 7 we drew a bubble 10 light-years around the Sun and found about 10 star systems inside it. A dozen porch lights scattered across counties. Draw that same 10 light-year bubble in the core of Omega Centauri and it holds tens of thousands of stars. The core runs hundreds of thousands of times denser than our street. So take out the grain of sand one last time. In our suburb, the next grain sat 18 miles away in New Jersey. Downtown, in the crowded pockets near the Galactic center, it sat a few city blocks away. In the core of Omega Centauri, the grains sit a couple of 1,000 feet apart in every direction, and in the deepest heart of the swarm, the spacing falls to a few hundred feet. One grain of sand, one football field, that is the floor. In all the Milky Way, the scoreboard never reads lower than this. Stand on a world in there, if you can find one, and look up. This is the sky Chapter 8 only hinted at. Thousands of stars blaze brighter than Venus ever manages over Earth. The nearest neighbours, sitting light weeks away instead of light years, shine down like a scatter of small moons, casting shadows, drowning the dark. Midnight in the core of Omega Centauri is bright enough to read this sentence by starlight alone, and it has been for 12 billion years. No creature evolving there would ever see the universe beyond the swarm, and no creature there would ever know night. And here, at last, the rule of this entire evening starts to bend, because even a few hundred feet between grains is, run the honest ratio, still emptiness, still tens of thousands of star widths of gap, and a single pass between two stars almost never ends in contact, even here. What breaks the rule is the same thing that breaks every rule eventually. Time, multiplied by traffic. 12 billion years, each of 10 million stars swinging through that packed core again and again. Thousands upon thousands of laps. Every close pass bending orbits. The heavy stars sinking toward the middle where the traffic runs thickest. Multiply 10 million stars by 12 billion years, and you get a number of chances so vast that even the rarest accident stops being rare. And the swarm keeps a matchmaker on staff. Binary stars. Pairs locked in orbit around each other. Sweep through the crowd like nets, snagging passing strangers into violent three-body tangles that usually end with someone flung away at terrific speed and, every so often, with two stars locked so close that they spiral together, closer and closer, until they touch, and merge, and become one. We know this happens, and the proof was found by a young man standing in a dead legend's shadow in 1953 at the Palomar and Mount Wilson observatories. A 27-year-old astronomer named Alan Sandage was doing patient, unglamorous work, measuring the brightness and colour of hundreds of stars, un by un, in a globular cluster called M3. Sandage had been hired as Edwin Hubble's observing assistant, the apprentice to the man of the red pen, and that same year Hubble died suddenly, leaving the young man to inherit the greatest research program in astronomy. But before all that, there was this cluster survey, and in it, a problem. When Sandage plotted his stars by colour and brightness, the chart of an ancient cluster came out wrong. A cluster 12 billion years old should contain no hot blue stars at all. Blue stars are the sprinters of the sky, burning huge and fast and dying young. And every blue star born with that cluster had been dead for over 10 billion years. Yet there they were on his chart, a scatter of impossible blue points, burning where nothing had any right to burn. Stars that looked billions of years younger than every neighbour around them. Sandage gave them the name they still carry. Blue stragglers. For decades they were a genuine embarrassment. Youth with no explanation, until the Hubble Space Telescope, fittingly, provided the clue, showing that blue stragglers crowd toward the centres of their clusters, precisely where the traffic is thickest, and the accepted explanations, two of them, both come down to the same beautiful crime. Some are vampires, one old star in a tight binary siphoning fuel off its companion until the thief blazes up hot and blue, and some are true mergers, two ancient stars, brought together by the swarm's endless shuffling, colliding and combining, their fuel mixed, their clocks reset, one star where two had been, reborn, burning blue, as if 12 billion years had never happened. So there it is, the second debt of the night, paid in full. There is one kind of place in our galaxy where the grains of sand finally touch, and what is born there should not exist. Stars younger than their own birthdays. Stars that are, each one of them, two stars. The rule that let Andromeda pass through us like a ghost holds everywhere in the Milky Way except the deep hearts of the old swarms, where matter is packed 100,000 times too tight, and time has been rolling the dice for 12 billion years. And even there, notice what it took. The densest address our galaxy owns, plus nearly the entire age of the universe, to make the sand grains meet. But before you fall in love with that blazing sky, that permanent silver midnight, those reborn blue suns, let me tell you what is missing from the paradise. Astronomers have gone looking, in swarms like this one, for planets, for solar systems, for anything like a home, and the search came back with a number, a single, brutal number, that I will show you in the next chapter, because that number is the reason you should be grateful, every single morning of your life, for 18 boring miles of New Jersey. Let's run the cruelest experiment of the night. It is imaginary. And thank goodness for that. Pick up the solar system. All of it. The grain of sand, sun. The dust speck Earth 4 inches away. The whole 20-foot studio apartment from Chapter 4. Plus the great fence of comets around it. The Oort cloud, we spent an entire evening mapping. Lift it out of the quiet suburb where it has idled for 4.5 billion years. Carry it 17,000 light-years south. And set it down gently in the core of Omega Centauri. Then start the clock. Stand back and watch what the crowd does to it. The first thing to die is the night. That happens instantly. The moment we arrive, the sky fills with thousands of blazing neighbours, the scattered small moons of the last chapter, and true darkness never falls again. It sounds almost charming until you remember what darkness does. Every discovery in tonight's story, Bessel's parallax, Hubble's red pen, the deep field, Rubin's flat curves, every one of them required a black sky to see faint things against. A civilization born in that core could learn its own swarm and nothing else. Sealed inside a ceiling of streetlights, the rest of the universe washed out forever. The crowd does not just threaten you, it blinds you. The second thing to die is the fence. Our Oort cloud reaches out more than a light year, and in the core, the neighbours sit light weeks away. The estate cannot fit on the new lot. From the first day, strangers are wading through our comet swarm the way Schultz's star did once in 70,000 years. Except here it is not once an era. It is constant. And the fence comes apart in a geological instant. Trillions of comets are stripped away into the crowd or shaken loose and sent falling inward. And the inner solar system, which in our suburb catches a bright naked-eye comet once a decade or so, finds itself under a rain of them that simply never stops. Then, slowly, patiently, the crowd comes for the planets. Understand. No star needs to hit anything. That is the terrible elegance of it. In our suburb, remember, a star passes within a few light years once every 100,000 years. And in 4.5 billion years nothing has ever come close enough to lay a finger on the planets. In the core, close passes come thousands of times more often, and every pass leans on the planet's orbits with a little gravitational thumb. One pass means nothing. 1,000,000 passes are a sentence. The outer planets go first. Their wide, lazy orbits the easiest to pry loose. Neptune and Uranus stretched, tilted, and finally stolen outright or flung into the dark. The survivors' orbits are stirred from calm circles into wild ellipses, and a world like Earth, which owes its oceans and its stable seasons to a nearly circular path held steady for eons, gets its thermostat smashed. Simulations of planetary systems in dense clusters keep returning the same verdict. Given enough time in the crowd, almost nothing keeps its original family. Somewhere in the first billion years, the odds say, Earth is either hurled out of the system entirely, to wander the swarm, frozen and alone, or left on an orbit that swings it from furnace to freezer. 4.5 billion quiet years, the time it actually took to get from the first cells to you, is not on the menu in Omega Centauri at all, and we have checked. This is the number I promised you. In 1999, a team led by the astronomer Ron Gilliland turned the Hubble Space Telescope on another great southern swarm, a cluster called 47 Tucanae, and stared at 34,000 of its stars continuously for more than a week, hunting for the tiny dips in starlight that betray a giant planet crossing its sun's face. Around ordinary stars in our own neighbourhood, planets like that are common enough that the survey should have caught roughly 17 of them. It caught 0. 17 expected. 0 found. I will keep the discipline, because science demands it here. Crowding is one suspect, and the cluster's ancient. Metal-poor chemistry, which makes planet-building material scarce, is another. And the truth is probably both working together. One ancient world has in fact turned up in a different cluster, circling the corpses of dead stars. One lonely exception after decades of searching, but the headline stands. We aimed our finest instrument at 34,000 suns in a crowd and found essentially no worlds. The places in our galaxy where the stars finally come together appear to be places where families of planets come apart. Now, bring the solar system home, set it back down in the Orion Spur, 18 scale miles from the nearest neighbour, and read our boring suburban ledger one more time, because after that experiment it should glow. One passing stranger every 100,000 years. And even the famous next appointment, Gliese 710, arriving in 1.3 million years, amounts to a visitor pausing at the far end of the yard once per geological era, an Oort cloud intact for 4.5 billion years, delivering its comets inward as a gentle drizzle instead of a storm. Planetary orbits so undisturbed that astronomers can run them backward and forward for billions of years like clockwork. A night sky dark enough to reveal Andromeda to a pair of Ice Age eyes, and to Hubble's 100-inch, and to a poet asking why the dark exists at all. 4 billion years of uninterrupted quiet, which happens to be almost exactly how long it took evolution, the slowest cook there is, to get from single cells to a creature that could look up and feel lonely. I want to say this part carefully, because it would be easy to say it wrong. I will not stand here and tell you the galaxy arranged its emptiness for our benefit, that the gaps were measured out with us in mind. Nobody knows any such thing, and this channel does not sell it. The honest sentence is smaller, and I think stranger. Life like ours seems to need an enormous amount of being left alone, and the emptiness is where the leaving alone comes from. We searched the crowded places and found no homes. We live in the empty place, and here we are. Read those two facts side by side, and the darkness over your backyard starts to look less like a desert and more like a setback, in the architect's sense of the word. The mandatory open space that keeps one fire from spreading to the next roof. So the ledger of the emptiness finally balances. And look how strange the totals are. The cost. We paid across 3 chapters. The silence of the wow signal. The painting in the starship window. A mother's message aging a year in flight. Isolation so deep that every civilization, if others exist, may live and die convinced it is alone. And the payment. We collected tonight. Stars that pass like ghosts instead of striking like cannonballs. A trillion-star collision with essentially no casualties. Orbits that hold for eons. Comets that stay on their shelves. Darkness you can discover a universe through. 4.5 billion years of nobody knocking on the door. Which is the same thing, it turns out, as 4.5 billion years of nobody kicking it down. All night we have asked the question in our title. Why is the galaxy so empty? One chapter remains, and its job is to put the whole night back together. The sand grains and the red pens, the swimming pools and the blue stragglers, the coin still spinning in the air over Helsinki, and then to turn the title around and read it the way. I would argue, it deserved to be read all along. We asked why the galaxy is so empty. We should have been asking what the emptiness is for. Come back to the backyard, the same one where we started. Hours ago now. The autumn sky, the crooked W of Cassiopeia, and below it, the faint grey smudge the size of a grain of rice. Find it one more time. I promise it does not look the same as it did when the night began. That smudge was a curiosity, the farthest thing your eye can see. 1 trillion suns falling toward us. Now you know what you are actually looking at. You are looking at 2.5 million-year-old light from 100 billion separated sand grains, each one whole New Jerseys from its neighbours, blurred into a single soft glow by the size of your eye and the honesty of physics. You know that if you swept up every star in it, the pile would fit in a couple of pickup trucks, and the room the pile came from would not fit between the Earth and the Moon. You know, the glow rides on an invisible ocean of fog and smoke weighing billions of suns, and that the ocean itself is the minor passenger, because 5 parts in 6 of that smudge is something with weight and no name, something a quiet woman in Washington proved was there by catching every galaxy in the sky spinning wrong. You are not looking at a crowd of stars. You have never once in your life looked at a crowd of stars. You are looking at an ocean of darkness, thinly lit at the shorelines, holding its shape across 13 billion years without any 2 pieces of it ever touching. Read the scoreboard one last time. Whole, because you earned every line of it. In our suburb, 1 grain of sand, 18 miles of nothing, and 1 visitor at the fence in the whole history of our species. Downtown, 1 grain of sand, 3 city blocks, and a sky of permanent silver twilight. And at the very bottom, in the 12-billion-year-old hearts of the great swarms, 1 grain of sand, 1 football field, and only there, at the floor of the entire galaxy, with 10 million stars and the whole age of the universe to work with, do the grains finally touch. And notice what the scoreboard brought at each level, because this is the finding of the night, where the grains keep their distance, planets hold their orbits for eons, comets stay on their shelves, the sky goes dark enough to discover a universe through, and life gets the 4 billion uninterrupted years it apparently needs. Where the grains close in, the night dies first, then the fence, then the worlds, and our finest telescope stared at 34,000 crowded suns and found essentially nothing left to stand on. The emptiness was never the desert in this story. The emptiness is where everything lives. That is the answer to the question in our title. And it comes in 2 layers. So let me give you both. Plainly, the way you would want them said if you had to carry them home. The first layer is arithmetic. Why are galaxies so empty when they contain billions of stars? Because billions is a small number and a galaxy is a large room. A star is under 1 million miles wide and the gaps run in trillions. And volume grows with the cube. And the cube eats crowds for breakfast. 100 billion of anything disappears when the room is big enough. And the room is that big. That layer explains the ghosts. Why Andromeda can drive through our living room and touch no furniture. Why the sun has danced 20 laps through 100 billion moving partners and never felt a bump. The second layer is the one I did not expect to find when I started writing this night. The emptiness is not leftover space. It is load-bearing. It is the banked fire that lets a galaxy burn for tens of billions of years instead of flashing out like a torch. It is the negotiating room that lets a junior galaxy's whisper rewrite the fate of 1 trillion stars. The coin still spinning in the air over Helsinki tonight. It is the setback between houses that has kept 1 particular pale blue speck of dust undisturbed. 4 inches from its grain of sand, long enough for the dust to sit up and start measuring. Take the emptiness away, and you do not get a richer galaxy. We checked. You get blind skies, broken fences, orphaned worlds, and blue fires burning where nothing should burn. The stars are what make a galaxy visible. The distances between them are what make a galaxy possible. And somewhere in the middle of all this, quietly, the people of this night answered a question none of them were asking. Think of who actually built tonight's answer. A schoolteacher's son on a freezing mountain with a red pen, who found out the smudges were oceans away. A deaf woman paid 30 cents an hour, whose tape measure he used. A broke poet who looked at the darkness everyone else stepped over and read the age of the universe in it. A photography boy from Nashville who proved the black patches were things. A mother taking night classes who caught the whole sky spinning wrong and, when they told her the mountain had no room for her, fixed it with scissors and paper. A volunteer at a kitchen table in Ohio, circling 72 seconds of hope. Not one of them touched the thing they measured. Every single discovery in tonight's story was made across a gap. By pull alone, mind reaching across emptiness the way gravity does, and I have stopped believing that is a coincidence. We are the murmuration that learned to look, a creature made of coordination across gaps, staring up at a galaxy made of coordination across gaps, and recognizing something. So here is what I would like you to do with all of this. And it is small. Some clear night soon, autumn or winter. Walk outside, away from the porch light, and let your eyes settle into the dark. Find the W, find the smudge, and then, for 1 minute, ignore the stars completely and look at the black. All of it. The gaps between the grains, the 18-mile silences, the room where the fog banks itself and the coin spins, and the light from the far shore has not arrived yet because the universe is young. Every other generation of humans who stood where you are standing saw that blackness as the absence of something. The empty seats in the theatre, the part of the sky where nothing is. You know better now. You are looking at the structure itself, the load-bearing dark, the setback that never burned. The reason the collision has no casualties, and the reason the quiet held long enough for you, personally, to be standing there looking at it. A galaxy is not a collection of stars. A galaxy is the vast darkness between them, held together long enough for light to form a pattern. And you live in the pattern's quietest corner, on a speck of stolen spin, 4 inches from a grain of sand, 18 miles from the next one, with the whole architecture of the emptiness standing guard around your one small porch light. The smudge is still up there, still falling toward us, and whether it ever arrives is a coin in the air. Either way, the grains will pass like ghosts, the dark will hold, and the room, the enormous, patient, protecting room, is the point, and it always was. Good night.